so I think he's swaying stuff. No concerns on the top side.
Good afternoon and welcome to today's media briefing here at NASA headquarters in Washington, D.C. The participants to my left are NASA Administrator Michael Griffin, and to his left, Associate Administrator for Space Operations, William Gerstenmaier. Now we'll have a few opening remarks to start off from the two, and then we will open it up to questions. Again, as normal procedure, we will ask that you identify yourself and your affiliate, and also limit yourself to one question and one follow-up so we can get everybody in. All right, with that said, this is NASA Administrator Michael Griffin.
Thanks, Dean. Actually, I'm not going to use up any of your all's time for opening remarks. Pleased we can be here today to help answer questions.
Okay, and again, it's my pleasure to be here. I'll just open up with a couple opening remarks on what the external tank foam team has been looking at. They reported to me again this week, like they did last week, and I can give you kind of a status of where they are, and then I'll open up the questions after that. Again, we're continuing the foam investigation. Last week we identified the major areas where foam came off the tank. We've now continued to refine data along those areas. We're starting to make some sense of the data and understand where things are coming together, what the mechanism for the foam loss was. We still don't have that fully understood, but the teams have made very good progress in understanding the basic mechanisms and kind of a go path forward way, or a way we're going to go ahead and address some of these activities. Along with that, we kind of looked at where we were in terms of launch opportunities. I think the last time I talked to you, I said September was pretty unlikely from a launch opportunity standpoint. We then looked at November and looked at January. And kind of from an overall standpoint, when we look at it, we think really March 4th is kind of the time frame that we're looking at, and we're going to do some more detailed plannings and assessments to go take a look at that March 4th date. That was driven by a variety of reasons. One was the foam investigation. It looks like we're going to have to do some repair at Michoud on the tanks, and then that will kind of push us into the time frame sometime after the first of the year, into 2006. And then the second piece was, this also gives us an opportunity to switch launch vehicles. If you remember, Atlantis was going to be the next vehicle to go fly, and then Atlantis would fly again on the 12A mission. And the reason Atlantis essentially flew back-to-back missions was that second mission, that 12A mission, carries the heavy P3, P4 truss. And Atlantis is a little more effective vehicle to go do that carrying of that heavy truss than Discovery is. So what this has allowed us to do now is now we can switch the launch order. Instead of going Atlantis, and then have to turn that same vehicle around, we can now go Discovery, Atlantis, and then back to Discovery. And that's a much better overall flight sequence when we go look at it. But to do that, we had to do replanning. We had to go do some new load development for the software for the shuttle. And when we looked at all that, to do that, we needed to move to next year. So both of those things kind of combined, and that said the right thing to do overall is to aim for a March launch sequence. The other thing that we're looking at is, instead of looking at these as individual shuttle flights, we're really looking at them as a series of flights that are integrated together to support the station. So how do we build the most robust manifest to support the station? In other words, how can we string these flights that give us not just a one-flight opportunity, but several flights, and really make the whole sequence flow much better? So when we step back and we look at it that way, it really makes sense to make this move to the March timeframe. Now, having said that, the way that the shuttle process works is we floated this March date out. Now we're going to go have all the engineers and all the field centers and all the developers go analyze that to make sure that that really all fits and it all kind of hangs together and there's no other issues there or any other long poles. So this will still be about a 2-week process before we really even kind of set an official date. So I wouldn't say that we've officially set the date there. We're still evaluating it, but it looks like the early opportunities don't make sense for us. They don't allow us to do effective planning. So we want to go ahead and move to the first period that fits from an overall standpoint, gives us a more robust station assembly sequence, and really sets us up in a better posture. So that's basically kind of where we are overall schedule-wise. And I would also say the teams are doing very good making very good progress at Michoud in understanding the foam and understanding what repairs we may have to go make. They're still not complete by any stretch of the imagination, but they're moving along in a good positive direction.
All right, let's go ahead and open it up to questions right now. And we'll start off right up front with Tracy.
Tracy Watson, USA Today. I guess for Mr. Gerstenmaier, can you tell us a little more about the progress that has been made on foam that allows you to think that March is achievable, please?
I think, again, I'm not picking March because we've made progress, but we're starting to understand kind of the areas that we want to do rework on. You know, I talked to you last time a little bit about the PAL ramp area. We're going to have to repair the PAL ramp, we think. How exactly we do that, we don't know yet. But we're still, the other piece is that we've got really good data from the flight experience. We got excellent data. Now the next thing we need is we want to take a look at some of the tanks that are already set up ready to go fly. So we want to dissect some of the PAL ramps that are on vehicles. So to do that, that's going to make us move some of those tanks to Michoud where we can do that. We're going to do some more non-destructive evaluation of those. So we got the basic plan for the PAL ramp of how we're going to go move forward together, some more data to, again, to try to find root cause and then pick a particular solution. As I talked to you before, the flange area, we think we're getting pretty comfortable with really probably no mods in the flange area. The acreage foam, we've got a strategy there. We're thinking of the next layer down, and then the ice frost ramps is still probably our most problematic from still understanding the root cause. We've got all the data together now, but we still haven't really laid that out. There's probably several root causes associated with the ice frost ramps, not just one. So again, I think the teams have done a very good job of taking the next step, sorting the data, putting it together, and they're ready to move forward.
Follow up. Is November, are November, December, January pretty much off the table now for sure? And given the amount of work you still have to do in finding root causes, can you handicap March for me a little bit?
Again, you could say November and the January are pretty much off the table once we start moving tanks around and start taking hardware apart. So that's there. I don't want to handicap March. Again, I want the teams to go work their 2-week process, let them go evaluate it, let them take a look at it, let them define the key milestones that we're going to go work at, and then let's see how all that fits. So in a couple of weeks, 2 weeks, 3 weeks, then we'll be able to give you some kind of estimate. But right now, that's just pure speculation. I don't want to speculate.
All right, a couple more questions here at headquarters before we go around the centers. Let's go with Keith right up front.
Keith Conning, NASAWatch.com for Mr. Gerstenmaier. Rather damning commentary in the minority report, in the task force report came out yesterday, which cites a lot of problems that may or may not have merit. Nonetheless, they have been cited. Part of the changes has apparently been the firing of several people at the top of the agency and your promotion. You were part of that activity. Other than your promotion and that of Mike Suffredini, nothing else has changed. Do you have a plan to address these issues? Has Dr. Griffin given you a plan? And if so, could you at least describe I know you've only been on the job, what, 2 days or so, just an idea of where you're going to go in addressing those issues?
Yeah, we really haven't discussed that. The report just came out yesterday. I've read through. We'll take a look at it. We'll evaluate it. And like any information we get, we're going to take a look at it and understand what we can pick out of it that's important and helps us to move forward. And we'll pick those pieces up. But other things we may discuss and see. There's even some. We need to read the report and really digest it. And then Mike and I need to discuss what really the go forward plan is.
Well, okay, Dr. Griffin, did you actually read those comments before you said include them, or did you just say all comments are welcome, I haven't read them yet, just put it in the report?
I was asked if I wanted to have the minority report or minority comments in the overall report, and I said yes, because, and I had not read them ahead of time, because frankly I think that as NASA, we do a disservice to ourselves and to our stakeholders and, frankly, to the taxpayers by creating an appearance that we do not wish to hear what people have to say if it should be negative. I think we do ourselves proud when we take all the comments that are given, we study them, we evaluate them, we investigate them, and we decide which ones make sense to us and that we wish to move forward on, and which ones where we don't think the advisors got it right. I think that's the proper way to treat advice, and I have conferred with the folks as recently as yesterday who provided those comments to us, and I believe that they fully understand the spirit of openness and honest acceptance that we're trying to convey to their issues.
All right, let's go with John, second row.
John Schwartz, the New York Times. This is, I guess, for Mike Griffin. For Gerstenmaier, what do the delays mean to the overall shuttle plan at this point? At what point does this delay now into March start to impinge really on what you're trying to do before 2010? And how does that squeeze what sort of squeeze does that put on your announced decision to reduce the number of flights?
Well, let me take it at first for policy level issues, and I'll let my colleague discuss manifest details. There's a change in thinking. If you will, to be honest, I'll put it on my shoulders. I've changed the game on shuttle thinking. We are not trying to get a specific number of flights out of the shuttle system. We are working toward an expeditious but an orderly retirement of the shuttle system over the next 5 years. And the President has said that, and I have echoed that NASA wishes to and will plan its program to comply with that. Now, what that means, given what we have learned about the shuttle in the time since Columbia, is that we need to view shuttle launches, shuttle missions as a process. We're going to work each mission through the process, being as careful as we can, as deliberate as we can, but with the intent, of course, to go fly. When we get to the end of that process, we'll fly. But we can't pick a specific number. What we're working toward is an orderly and expeditious flyout of the system. We're going to use the shuttle system between now and then to assemble the space station. The United States has a commitment to itself and to its partners to complete the station. We believe that if we can, absent major problems, we believe that we can essentially complete the assembly of the space station with the shuttle fleet in the time that we have remaining, and that's what we're going to try to do. We will, of course, after every flight, face up to whatever facts, whatever cards nature is dealing us in this hand, and we'll face up to that. But our planning is to use the shuttle fleet to essentially complete the assembly of the space station in the years that we have remaining, and that's what we're trying to do.
The only thing I'd add is that, again, by being able to do this vehicle switch that I described to you, that's going to actually make a more efficient manifest that really makes the impact of moving into the March timeframe from kind of a macro standpoint not a very big impact to us. It's still going to allow us to essentially, at least conceptually, think about flying about the same number of flights. And again, we'll treat them just as Mike said. We're going to treat each one unique and make sure we're ready to go fly a unique test flight and go forward. But again, it doesn't seem to be a major impact at first look.
All right, we're going to come back to headquarters. We have some media members at Kennedy Space Center, and we'll take the first question from there now.
Hi, this is Bill Hart with CBS with two quick questions. A very quick one to Bill Gerstenmaier. Can I assume that when we do fly again that it will still be 2 flights in daylight to verify your processes before you can go back to night launches?
Again, I think we ought to not jump to those conclusions. We ought to the data we see, make decisions about what we want to do next. So rather than speculate on what performance we're going to see, speculate on what we're going to go do, let's let the data talk to us. Let's see what we actually see on this next flight and see what we get, and then make some of those decisions.
And for Mike Griffin, if I could, given the minority report, what it said, and given the fact that you did have a foam problem that was fairly unexpected, I think, for SPS 114, do you have any sense that the management system that's in place in the shuttle program, are you planning to leave that intact the way it is? Do you sense any crisis of confidence? I hate to use a trite phrase, but I think some people might view it that way just given the sequence of events and how you view your current management structure.
Well, I don't want to make specific comments on that because we haven't, Bill and I have not thought our way through it, to be honest. When and if we want to make changes there, you know, those will become public knowledge. But let me address the more important question of, is there some crisis in confidence? No, there's not. There may be. There may very well be, in accordance with the comments made in the Stafford Covey report, some issues that we need to address regarding engineering process and engineering management, engineering discipline, those sorts of things. We've worked hard at NASA over the last 2.5 years to improve that situation that led to the loss of Columbia. But we don't suppose that we're done. And one of the reasons why I was very receptive to the minority report was because we can't get done unless we're willing to listen to all of the hard truths. So we're going to be looking at our engineering processes, but let me illustrate what I see. For good or ill, and obviously it was for ill, okay, poor choice of words on my part, we in NASA didn't look in detail at foam shedding from the tank for 113 flights. And shame on us. Absolutely everyone in and out of NASA learned a lesson, I hope, about that. And that is an incident, that is a process that will be examined in textbooks for years to come. We flew 113 flights without seriously addressing the issue of how much foam was coming off the tank, why, where, and what it was doing. Okay. So on the first flight, after being hit very hard as an agency can be hit by a mistake, with the loss of 7 lives, we stood down for 2.5 years to try to fix the problem. So on the first flight, after we started really paying attention to the foam, almost everything we did worked. There are, I think, 5 areas where it didn't work right. And one of them with the PAL-RAM foam was a big piece and, you know, very embarrassing. But there were 5 areas that didn't work right, and almost everything did work right. So do I have a crisis of confidence in the team that made almost everything work right? Of course not. As Bill just said a few minutes ago, we're going to take the data and see where it leads us, and we're going to fix those things that we didn't get right. But in a very important sense, this was the first try that the tank team, the shuttle team, the NASA team ever really made to reduce the foam shedding to a minimal and acceptable level. I think they did pretty darn well for the first try, and that's how I'd like for people to view it.
All right, I believe we have a couple more questions out in Florida.
This is Irene with Reuters, also for Mike Griffin. I know you haven't had time to digest and analyze the report, especially that minority report written by the 7 members, but could you tell us a little bit what rang true to you, and if things like your intervention about the ice concerns and the installation of the heaters is true? Was that pretty much your idea to step in and stop things at that point? And what is it that you see still needs to be done from a process standpoint, how your people go about solving these problems? And then related to that, your upper management changes, are these related to things that you see you want to have the agency move toward?
That was a lot of questions. Let me do my best. First of all, Irene, my role in, quote, stopping things, as you put it, has been exaggerated to the point where it's in danger of becoming an urban legend. When I joined the agency, I pledged to the Congress, to the White House, to to NASA's stakeholders throughout the nation that the safe flight of every shuttle would be my first priority. I do have an engineering background. I therefore thought that the best use of that background was to be as involved as I could possibly be and as cognizant as I could possibly be of what we were doing to return to flight, how we were doing it, how well it was proceeding, and all the things that go with that. And I will do that for every flight. That's the best use of my time and my training. We have other people who can handle other things that I don't do as well. It's a team effort. So therefore, in view of that priority, I attended every shuttle review that was of a significance to attend between the time I joined and our actual launch. In one of those, there were some issues that were raised. I had some comments about our engineering process and what we were trying to do and how long it was going to take to get the results we needed. Other people, many other people, had comments as well. There were issues with regard to engine cutoff sensors that I think you remember from last month. There were issues about ice, issues about foam, issues about tank heaters. Would we or would we not do another tanking test? The sum and substance of all those issues led the team to come to the conclusion that we really weren't ready to go in May, that we would be ready to go in July. And, you know, this is what I said 3 months ago when the topic came up, and it's what I'm saying now because it's what really happened. Did I have a role? Yeah, I had a role. I would hate to say that I went to an engineering review and sat there like a potted plant. On the other hand, we did not emerge from that review with the direction that Mike says we're delaying the launch. I mean, that didn't happen. So I'd rather not have it categorized that way.
I believe we have one more question at KSC.
Yes, hi, this is Marcia Dunn with the Associated Press for the administrator. I was just wondering, it took 2.5 years to get to this point, and yet the criticism in the minority report says that the behavioral issues still exist. And I'm wondering how you can hope to launch in March or any time thereafter, just half a year away, with so many of these behavioral issues still unresolved.
Well, because the minority report says that some of the behavioral issues that were cited as leading to the loss of Columbia still exist or existed with some people, does not mean that huge improvements haven't been made. So let me turn that around. I think huge improvements have been made. Bill Gerstenmaier, my colleague to my left here, is among the very most respected engineering managers in NASA. I think it is safe to say that he may have some peers, but he has no superiors. With that in mind, with that certain knowledge in mind, I asked him to assume leadership of space operations. The prior team had, I believe, given their all to return the shuttle to flight. And in the process of putting my management team together for the next few years, I selected Bill. We have not had a chance. As someone else pointed out, he's been on the job for 2-3 days. It's kind of a tough gig to change from being the space station program manager to being the head of manned spaceflight at NASA. And frankly, I'm still getting my feet on the ground after 4 months as the administrator. So I want to assure everybody that we will go over in detail the minority report, as frankly, as well as the majority report in the Stafford-Covey Task Group report. We'll go over it all, and we will decide what we want to do in as responsible a fashion as we can muster. But I'm just not going to sit here and make off-the-cuff speculative remarks about how we're going to handle a report that we received yesterday. In fact, if I were to do that, it would be to denigrate the report and the people who prepared it. The Stafford-Covey Task Group spent 2 years working with this agency and several months preparing this report, and it deserves a careful, measured study, evaluation, and a careful response by Space Ops and by me as to what we're going to do about it.
Just a follow-up for you, sir. some of the criticism also was against all the multiple launch dates that were totally unrealistic, which led to shortcut repairs and things not being taken into as in-depth as desired. Is there going to be a real effort by both of you up there to not put out launch dates that are really unrealistic, just a few months out, just only to change them and keep bumping along?
Well, exactly, and that's why, you know, right after the launch of Discovery, when the foam loss on the Powell ramp came up, and everyone was pressing to say, well, does that rule out September or whatever? And I was saying, well, no, let's get some data, let's figure out what's going on, and then we'll tell you what we think we can do. So now Gerst has outlined for you a very conservative plan to do the second test flight in the shuttle's return to flight sequence, which isn't trying for September, isn't trying for November, December, January, February, is going all the way out to March in an effort to give people some time for a planning horizon. And so now everybody's coming back and saying, why can't you make November? We are trying to insert the necessary conservatism in this. And that's why we're going out as far as March and giving ourselves what we hope is plenty of time to evaluate where we are. Now, again, we got a tremendous amount of data off this flight, and we don't see that the task remaining before us is as difficult as the tasks we have behind us.
And I would caution you again that we shouldn't be thinking of the launch date as March. You know, what I described to you was that we put a planning target out there, and now we're going to go do a detailed engineering assessment and analysis and start seeing if that makes sense. We'll factor in what we learned from the tank. We'll factor those things in. And then when a couple weeks have gone by and we've got enough intelligence together, then we can pick a launch date. So we're really not picking a launch date. What you're seeing us do is do planning. And we need to decouple this launch date setting with the normal planning process that the program has to go through to arrive at a decision.
Yeah, if we don't put March out there to the team and then ask the question of what do we have to do to make March, we never get those answers. But of course, the minute we mention it, it then becomes public knowledge, and now that's the launch date. It's a little hard.
All right, let's come back to headquarters for 2 questions before we go out to JSC. Brian?
Brian Berger with Space News and Space.com for Bill. Back in the spring time frame, on the evening of a Stafford Covey meeting, it was canceled, and word got out pretty quickly that Dan Crippen and the other members of the minority report were raising concerns, were protesting the way that the rest of the Stafford Covey group was going. What did NASA know about that at the time, and what did NASA do to respond to those concerns raised by Dr. Crippen and others?
To be frank, I really don't know. I was doing station program management at the time, and I wasn't involved in any of that, so I don't have any insight or any knowledge of that at all.
I can answer some of that, and I will, because I don't want to be unresponsive. I was apprised that there were concerns by a group on the task group who didn't necessarily agree with the minority, and I was asked at that time, for the first time, how would I prefer to handle that? I said, let them speak their mind. Let them tell us what they think, and we will listen. I've tried to put out a message on a number of occasions that NASA line management is in charge of the civil space program. The President reinforced that a week or 2 ago in his comments during the Discovery mission, that NASA will decide what to do with the shuttle and other issues. So we are accountable and responsible. Bill and I and others are accountable and responsible for what we do here in the civil space program. Advisory groups advise. We welcome the advice because it is very hard when you're immersed in the day-to-day struggle to figure out the right thing, do the right thing, and make the hard decisions. It's very hard to pull back and look at things from a big picture perspective, and so NASA often uses knowledgeable but external advisors to help us shape our decision making. But at the end of the day, those groups are not accountable and not responsible for what they suggest. They provide information that we use to evaluate our course of action, and that's what we will do with the Stafford Covey Task Group report or with any other report that we commission. So when I was asked the question, do you want to hear this stuff? The only answer I could ever give would be, yeah, I want to hear it. I want to hear what people have to say, and then we'll evaluate it. We do not shrink in NASA from criticism of our engineering processes, our decisions, or anything else. We will listen to it, we'll evaluate, then we'll make a decision, and we'll move on, and our superiors and stakeholders will judge us for what we have done.
All right. One follow-up. We're running out of time, though.
Yes, on what you were doing at that time when you were asked the question, how you would handle it. So could you clarify how you were asked for your opinion of how you would have handled the situation with Dan Crippen and the others at the time?
I actually don't remember. I received, I believe, a call either from Tom Spafford or Dick Covey, both of whom are old friends, and was apprised that there was some dissent within the group and a discussion of whether a minority report would be issued, and would I be receptive to that? And my attitude was exactly what I have conveyed to you. We are ready to hear whatever it is that people have to say.
Let's go to Johnson Space.
Dick and Tom said, fine.
Sorry to interrupt there.
Yeah, pardon me. I wanted to add that last bit, but Dick and Tom then just said, let's go forward. There was no issue.
All right, we have a few minutes left. Let's go to Johnson Space Flight Center for a question.
Mark Carreau from the Houston Chronicle to Bill Gerstenmaier. At the top of your remarks, you mentioned that your teams in Michoud are looking at some root cause and potential repairs. Could you elaborate, especially with regard to the PAL ramp? What kind of mechanism do you think you're seeing, and how would you go about repairing?
Again, kind of like I described last week, probably the leading thing we're thinking about is removing the existing PAL ramp and then spraying a new PAL ramp in place of the one we took off. And we think we can do a better job from a spray standpoint, we can do a better job from an overall installation standpoint, and then that'll also be a fresh ramp that we've installed. Now, as I say that, we have to be cautious that we're spraying this PAL ramp on top of the foam acreage that sits below it, and you can think of that as the foundation that sits below it. So we need to understand and make sure that that foundation we're putting it on is a viable foundation, is going to be as strong as the ramp we're adding on the top. So again, I'm kind of sharing with you what the team is thinking about, but you don't want to just jump to one conclusion and not test that conclusion and make sure you're really doing the right thing. So we're going to take some of the tanks that we've already put foam on, and we're going to dissect those. We're going to do some more NDE with them. Now that we have you have the luxury of hindsight. You saw when the foam came off, you saw where it came off, you understand what time it came off, you know the velocity it came off, you know the size of the piece that came off. Now we can take our NDE back on some of those other tanks and take that knowledge we now have of the failure and see if that can give us any more insight. So before we pick a particular repair technique, we're going to understand every bit of data we can get out of the existing tanks. We're going to make sure that we've got a good solid foundation. We're going to what if this back and forth and make sure we got the right repair philosophy that's going to ensure to a high probability we won't have this type of event, or the event will occur so late in the sequence that it's not a problem to us. That's the other dimension we have here that we sometimes don't talk about. You know, after about 135 seconds or so, foam loss is really not a problem to us because we can't get enough delta velocity for it to cause us a problem. So we can either ensure no foam comes off, or we can ensure that it's going to come off after a point in the sequence when it doesn't matter to us from a velocity standpoint. So we're going to factor both of those together, but we still have a lot of work before we pick a particular repair technique. And I gave you kind of insight in the leading repair technique, and just be cautious that you don't put that down and then next week when we get more data we change it. We're going to let the data drive us and tell us which way we want to go and what we want to go do.
All right, let's go to Marshall Space Flight Center.
Hi, Steve Johnson from News Channel 19. My question is for Bill Gerstenmaier. Obviously, the delay is going to allow you more time to work out the foam problems. Is it also a benefit, say, here at Marshall for the propulsion folks? I mean, is there a benefit in not launching until next March? Will they be able to accomplish something new?
again, I think when you get a slip, you take a look at it and you figure out how you can use that to your best advantage, and that's part of this review process that the teams are going through. Is some of the teams won't be impacted by this, and they may be able to add some new activities. You need to be careful when you add new activities that you don't push the schedule or put more risk in the system, but we'll go evaluate that. So we've got the new dimension of a little bit of extra time, and each one of the teams will take a look at it, they'll evaluate it, and then the program will discuss it in details over this 2-week or 3-week review.
All right, let's go to Ames.
Hi, this is Matt Bigler, KCBS Radio in San Francisco. And the question is about the Ames Research Center here. What role will Ames be playing in testing the foam issue and preparing the shuttle for launch if that is an eventuality come next year?
Again, I think some of the teams are still formulating what kind of testing we want to do, if we want to do any more wind tunnel testing. There may be something come along those lines that we'd like to use Ames for. Clearly in the aerodynamics region and some of that activity, we may ask some work from Ames there. Sometime in the future, we'd probably like to remove the POW ramp, and to understand the ability to remove the POW ramp, we need to look at the aerodynamic conditions of the cable tray that sits there in the press lines, and we'll involve Ames or the right research folks throughout the agency to help us with this. And that's one of the neat things about NASA is the fact we have essentially a large pool of resources and engineering talent that we can pull on throughout the agency to help us with these problems and these issues that come up. It's a tremendous pleasure for me to be able to have the ability to go ask whoever I need to go do to help me understand a test or data and get an immediate response that, hey, we're willing to help. And it's a tremendous testimony to the way NASA can work as a team and pull together from the multiple centers to support what we're trying to do here.
Let's come back to headquarters for one question before we close it out.
Thank you. Jeff Morris with Aerospace Daily for either gentleman. At what point does the slip in this second test flight mission begin to impact the decision-making window for a Hubble mission?
Well, I mean, from a budget perspective, obviously we need data from the last shuttle flight, the upcoming shuttle flights, to be able to make a Hubble decision. I've said that from the first. I have said that I would like to do a Hubble servicing mission if we can do it, but that if we can do it depended on the results of these flight experiences. It's really just a budgetary issue. The longer we go without committing to do or not do a Hubble servicing mission, the more that we have to, of course, carry the budgetary protection to do it, and the more it costs us. The running cost of that past December of '07 is about $10 million a month. Okay, as best we can calculate it right now. We're not going to make a decision based on that fact. I'm just telling you that that's what it costs us if we defer out past December of '07.
All right, thank you. That'll conclude the question and answer. I want to give the opportunity to Mr. Gerstenmaier or the administrator for final remarks.
I really have nothing to add. I will add that I'm pretty excited getting up here to headquarters and getting a chance to work with these teams. I worked in the past with the shuttle team, and I worked a lot with the station team. And to be up here and know what engineering skill and the personnel that I have behind me at the field centers, both at Johnson and Marshall and Kennedy and even Ames and then Langley and Glenn, where I came from, it's a tremendous privilege for me to be up here to be able to represent them and to call on them and pull from the pool of talent that's out there to solve these problems. It's a neat thing to be up here, and I feel privileged to be up here, but it's great having that team behind me because I know there's an awesome team back there that's really willing to work.
Well, good morning, everybody, and welcome to the Johnson Space Center. I'm pleased to introduce our briefers for today's update on activities around the Space Shuttle program and the International Space Station program as well. This briefing today, we're joined by Bill Gerstenmaier, who is the Associate Administrator for Space Operations. Also joining us is Wayne Hale, who is the Space Shuttle Program Manager. Also joining us is Rick Gilbrecht. He is the Deputy Director of the Langley Research Center. He also is the leader of the External Tank Tiger team. And we'll hear from all three brief comments before we throw it open for questions. And we'll start on the end with Rick.
Thank you, Kyle. Well, good morning. I thought I'd give you a little background on our Tiger team, how it came about, the membership, and then what our charter was. We were contacted by Bill Gerstenmaier and Chief Officer of Safety and Mission Assurance, Brian O'Connor, right after the STS-114 launch, and we actually were formed while the Discovery was on orbit. And the main drive of the Tiger team was to look at the root causes of the foam loss on STS-114, try to determine if they were unique to that particular flight and that particular tank. And then secondary, we were to look at any near-term recommendations that we would give to be implemented before the next flight. And lastly, to look at long-term improvements that the external tank and the shuttle project should consider. And I wanted to say first off that I have a healthy appreciation for the difficulty of the external tank project with foam. It's a very difficult challenge that they're trying to address with the foam. And basically, before Columbia, foam its main purpose was to provide insulation to keep the propellants cold, and also to prevent the ascent or protect the tank from the ascent heating, from air frictional heating during ascent. After Columbia, we learned that we needed to treat foam as a structure, and foam is very difficult, and it's basically in its infancy as far as understanding it as a piece of structure. And there's a lot of difficulty there because foam, by its very nature, is meant to insulate, which means it's basically mostly air. And so on the one hand, you're competing with wanting it to be an insulator and mostly air, but you also require it to be structurally sound and withstand the stresses on launch and ascent. So those two are competing against each other. You also have large temperature differences the foam has to withstand. You've got a 600-degree difference from one side of the foam to the other, and that puts a lot of stresses in the foam. It's also a very difficult material to model and analyze because it's not as well understood. I equate it basically to steel, the understanding that we had of steel as we came out of the Industrial Revolution. We're basically at that point with foam. And there's been a lot of progress made, but we've still got work to do. I did want to note we ran across a lot of good things since Columbia. I mean, there were a lot of improvements made after Columbia. Of course, we have better imagery. That's why we have so much data to digest on the ascent imagery. There were significant improvements in the manual spray techniques that were applied to the tank for STS-114. They've made a lot of improvements in the non-destructive evaluation techniques and also the modeling of the foam. So a lot of good things there. My team's basic approach was to look at three different areas. Look at the environment that the shuttle flew through on ascent, and basically our conclusion was there was nothing there that pointed to anything unique. Everything was pretty well enveloped by other flights. We also looked at materials, see if there were any clues in that arena. And the only difference really was at the protuberance airload ramp, which was the part that lost the biggest piece of foam. This was the first flight of a BX-265 foam formulation. The other foam had to be discontinued because of environmental reasons, and this was the first flight of the new foam. So, and then the third thing we looked at was processing. Was there anything in the way this tank was processed that might give us a clue as to why we had lost foam? And the major finding we found was that this tank was reworked to a level that none of the other tanks prior had been, and we suspect that handling damage or collateral damage, as you may have heard, which is basically risk to the foam from technicians that have to be there and doing their work, we think is a potential contributor. And I want to make it clear that we found no negligence on the part of the workers at the ET project. They were doing their work per procedure. It's just we didn't really have an appreciation for the significance that this handling damage could have in terms of foam loss. We eventually came out with 15 near-term recommendations and 7 long-term recommendations.
And the program has responded back with an action plan to address each of those recommendations. We have that in review and work with the project to make sure they clearly understand the intent of the recommendations and that we're satisfied that their test analysis and inspection plans are adequate to address those. And I guess lastly, we did try to look at other factors beyond technical. I'm sure a lot of people's minds, wonder with schedule pressure, contributor. The only real, we did come up with one lesson out of our report that talks to things that we want to learn for future programs. And the only real schedule issue we ran across was in the decision, they replaced the forward 10 feet of protuberance airload ramp and resprayed it with an enhanced spray. And there was a debate over whether to replace the aft 28 feet, and of course that was a section that the large piece of power amp was released from. At the time, there was a good, open, healthy technical debate, and all the different opinions were put on the table. And they had done some dissections of other flight tanks and mock-up sprays and compared those, the old sprays with the new enhanced sprays. And at the time, it basically was a wash. The data did not point you in either direction. And so they backed then into the second factor that normally you would look at, which is schedule. And so, with all things being equal, the fly as is phone decision was a good decision based on schedule. So we really found no fault at the time of the decision. The only thing we would note is that there was subsequent testing and dissection that was done that showed an improvement actually by the time they wound up doing the enhanced spray. So. And also there was really no crisp requirement as to what was good enough, and that's something that is always going to be a difficulty with foam, but again, when you can, you would like to be able to set a crisp requirement and then set out to meet it and not proceed until you do. So that was my comment.
Okay, Wayne. Well, thank you. I have three topics I want to address in my opening remarks. A technical item regarding the foam, a discussion of what's going on at Michoud and also the Stennis Space Center after the hurricanes. And then I want to talk about scheduling and the discussions that we had and the program board yesterday. The first thing I want to talk about a little bit is the fact that after the Columbia accident, many folks that work in high reliability, high risk organizations told us that what is very important is to maintain an engineering curiosity and always be willing to look for new and innovative ways to get data, information about what is going on with your flight vehicle in our instance. We made a large investment in NASA inside the Shuttle program in some ground infrastructure that will allow us much more information about the launch environment, the early phases of flight. I think you've seen much of that. We made a large investment in upgrading the ground cameras in the visual sense to get better information about the launch. One of the other areas that we really have taken to a new level is our radar tracking. We've always tracked the launch vehicle for range safety purposes, but that's concentrated on the main vehicle, and the radars are looking, frankly, for a large vehicle, not small objects. The state of radar has progressed dramatically in the last few decades, and there are new radars available that can track small objects in the vicinity of large objects, and we made quite an investment in the debris tracking radar system, which will benefit not just the shuttle, but all the vehicles that launch from the Kennedy Space Center, and will be available, for the exploration purposes as they come online later. Let me put up a graph, if I could, that shows you some of the data that we have received from our launch in STS-114. We are treating all these flights as test flights, trying to get new data. And what this shows you is the evaluation of the radar data that when we saw debris items in the trail of the vehicle during flight. Now, one of the very interesting things is, as you know, we have never gone out to say we're going to have no debris come off the tank. We're trying to address the critical debris. We know that there is small popcorn debris which would be very difficult to eliminate, that comes off the tank. What this graph basically shows you, I think, is that we're able to see a lot of that stuff, not just the big pieces, but the very small pieces at the very late times. And what is really important is not just what comes off, but when it does in fact come off, what do we need to worry about? You could almost draw a line at 135 seconds mission elapsed, because at that point the altitude and the air pressure is such that anything that comes off the stack cannot achieve enough energy to cause any damage if it should come back and collide later on with the orbiter with other parts. And you'll see that there is a marked population of tracks that we saw that happened, and by the way, this is beyond visual range. The cameras cannot see this. This is something that only these new radars can see. We have emerging physics coming out that indicate that we are beginning to postulate some understanding of why this foam comes off this late. Now, why this is important is the foam that comes off late is not a threat. The debris that would occur after about 135 seconds is something that we literally don't need to spend resources fixing. Now, obviously, there are a couple of pieces that came off early. Those are the things that we're going to concentrate on. But there are some areas that we saw foam loss in, for example, the ET separation pictures that were taken at the end of ascent that show foam came off the tank. The point is, if it came off late and we have an understanding that shows that it only comes off late, then it literally will not be a safety risk for us, and we do not, in fact, have to, in the near term, although you would like to in the long term, address it. You don't have to fix that in the near term. This story is emerging, as I said. We have some more work to do, but I think it's indicative of the kind of inquisitiveness that you have to have as an engineering organization if you're going to fly in a high-risk environment, as spaceflight always is. So to my second topic, which is talking a little bit about Michoud. As you know, the external tank and the work that's been done in the external tank and resolving the issues with the foam are the critical issues that we have to do before we return to flight. The hurricanes, Katrina principally, but also Rita to a lesser extent, caused damage and caused loss of time. And I think if you've been watching the NASA television and in fact some of the other media reports, you'll know that our plant in Michoud came through very well. In fact, when the emergency response forces first came to New Orleans, on the east side of New Orleans, our facility at Michoud was a major staging area for literally hundreds to thousands of National Guard troops, Coast Guard folks, and other emergency responders, because it was one of the few areas in that part of geography that was dry, that had an infrastructure that could allow the emergency response people to come in and work from there. This is a great example of the kind of planning that went into our hurricane response effort, similar to what we saw at the Kennedy Space Center last year when they had hurricane damage down there, that allowed us to bounce back. Our biggest problem, frankly, at Michoud is not the damage to the plant or the NASA facility itself. It's the infrastructure and our workers' homes and highways to get to the plant and so on and so forth. We have estimates that basically we will have lost the equivalent of 3 months worth of work at Michoud based on the effects of the hurricanes. In spite of that, our amazing workforce down there is coming back to work. We are making outstanding progress in addressing these issues. I think it's important to note when you talk about the economic recovery of the New Orleans area and East Louisiana, NASA and our contractor Lockheed Martin employ over 2,000 people in that area. These are professional folks that will contribute to the economic recovery of the area, and we have work for them today. And I know as you look at some of the recovery in New Orleans, folks are worried about having jobs in the area, and I'm pleased to say that NASA and Lockheed Martin are contributing not just to the nation's space program, but to the economic recovery of that area. We are ramping up in workers. We have over 500 workers a day right now in the facility, and that will increase over the next few weeks as the infrastructure improves. And we clearly are anxious to have the people there. We're told, I've been told, talked to several of the folks involved, that the workers are anxious to be back at work. They're very proud of what they do and know that they are critical to the success of the space shuttle and are anxious to get back in the plant and start working. And so we're ramping that workforce up as quickly as the roads and water supply and electricity and those sort of things will allow. It is really miraculous what they have done at Michoud in terms of the workforce turning out in spite of the personal losses that many of them have undergone, and my hat is off to the workforce there. The third topic, and I'm sorry to have such a long discourse here, but I really do have a number of things I wanted to say. The third topic is a discussion of schedules. You know, we have a number of reasons that we need schedules inside the program. Part of the discussion that we had yesterday was the safety improvements that we want to perform on the Space Shuttle orbiters. We have a new, hardened, tougher tile system that we would like to start installing on the underside of the Space Shuttle orbiters that will make us more impervious or less susceptible to debris impact damage. This BRE-18 tile is much stronger. And as we go through, we would like to replace tiles in many critical areas with this impact-tolerant tile, which will protect us if we do have debris strikes. But we can buy that by the yard. You know, we have 24,000 tile on the bottom of the orbiter, and clearly you can't replace all of those at once. It's a process that we're going to do over time. So it's important for us to know approximately when the tank will be there, to know approximately when we might launch, to know how to schedule the workforce that is putting tile on, frankly, on the bottom of the orbiters. So it's important for us to have a schedule for the orbiter folks to work to, and the ground processing folks at the Kennedy Space Center. Similarly, the flight design people, the crew training people, all of those folks that have work to do need to plan their work efficiently as they can toward a date. We have not set an official launch date. I want to make that very clear. The shuttle launch date for the next shuttle flight has been in the lingo that the Eastern Range uses, indeterminate, since the foam incident on STS-114. We are, however, working toward technical solutions of our problems, and we are at the point where we believe we have an understanding of the parameters of those problems well enough in hand so that we can give internal working schedules to the rest of our elements. Of course, any schedule we have is going to be critically dependent on the work that goes on at Michoud, and that's why the discussion of the workforce and the workforce returning to Michoud is critical to our scheduling effort. We believe we understand how that is going to take place over the next few weeks. Final schedule setting will depend on how rapidly we can get people back online, and frankly on the results of several of the critical tests that Rick Gilbert's team and others have proposed that we need to do before we can return the tank to flying condition. So we have a number of critical things ahead of us that we have to evaluate before we set an official launch schedule. However, based on the discussions that we had at the program board yesterday, it appears that the May launch window is something that we can begin to work toward now. And that launch window, our orbital trajectory folks tell me, extends from May 3rd to May 23rd. We are starting to put our internal schedules together to work toward those launch dates. I asked again for all the elements of the program to come back and give me an evaluation in about 2 weeks of the work that they could do to meet that schedule. But before we set an official launch date, we have got to get through some of the near-term work and see how we're progressing with the external tank. I know everybody is anxious for us to set a launch date. All of you would like to have a headline that says NASA sets a launch date. We are working toward coming to you in the near future, I think, with that kind of information. But as we stand today, we are putting our plans together to fix the foam on the external tank to respond to these issues that Rick has described to you. And we're looking to see, frankly, how we can get the Michoud facility back online to support those efforts before we set an official launch date. I think we're beginning to have our hands well around the technical problems that we have and to find the fixes that are going to be necessary to fly again. So those things look like they're coming together toward May. And with that, I'll turn it over to Bill.
All right, thanks, Wayne. Thanks, Rick. Again, I'd just like to thank Rick and his team for doing this investigation and pulling together a very crisp story for us on the tank and the foam activities. And as Rick described to you, the foam is very tough to analyze, and his team's insight into the foam and its material properties have been really helpful to the project teams as they go forward and help focus some of our work in the forward direction. I'd also like to thank Wayne and his team for pulling together these things. You know, we don't say we set a launch date, but we're clearly aiming for May. They've done all the analysis that looks together, and May looks very doable from an overall standpoint. But the fine details, we still need to work and see how things work out overall and see how we actually get back to production. So again, I think they've done a great job of analyzing this, understanding the critical path, understanding all the key events that need to occur as we approach the May date. And we've also accepted some challenges where we're going to go ahead and do some activities on the tank. We'll be spraying some foam before some testing is complete. Again, they've done a great job of analyzing and understanding, is that the right thing to do? Is it a reasonable schedule risk to go ahead and start some of these activities before you're fully tested? And we think that that's clearly the right thing to do overall. So again, they've done a tremendous job of putting together a very good schedule. And then the last thing I'd just like to amplify shortly is that the Michoud workers have just done a phenomenal job. They've done some auto spray of foam down at the Michoud facility already. They've done some manual sprays, starting to do some validation and verification to actually get back. They did these sprays on a test tank to get back to actually start spraying the real tank. And they've shown a tremendous dedication, a tremendous desire to do what they want to do, to show up to work, to go do this activity and help us out. And I think they're kind of exemplary of the support that we get throughout the shuttle program. What a pleasure it is for me to be kind of in charge of both of these programs and have a workforce that's so dedicated that is willing to put aside personal strife and personal problems to show up to work to make sure that they can get back to the job that they want to do so we can get back to space. What a great sense of humbling it is for me to work with such a great workforce, and I sure appreciate it. So we look forward to your questions, and thanks.
Okay, we've got 5 different locations with questions and about a half an hour to get through it. So try on the first round to limit it to 1 question. We'll start here, name and affiliation, and if you can address the person to which the question is headed. And we'll start right here with Mark.
Mark Carreau from the Houston Chronicle. The 2 points I have are sort of connected. So what did you find about the foam application procedure and the foam material itself that contributed to the problem, and what's the prescription for the fix?
Well, there's what we found are several potential contributing factors to the foam. Some was the way it was sprayed. In the old process, there was you would get knit lines, which are at the interface between the foam as you do passes, and that's a concern that we've got some test and analysis working on. Also, this worker traffic, the fact that there was rework done in that area is another potential contributor, and so there's a test plan to actually see how much force it takes to crush foam do some material testing and find out how much of the properties weaken, and then actually try to do a combined environments test as close as you can to flight to see if crushed foam by itself would have caused the release. So those are some of the activities going on. But we don't really have a unique one. We do know it was a combination of multiple factors, and we don't believe any one in and of itself would have caused the release. So we're attacking as many potential contributors as we can and trying to eliminate those.
Gina.
Gina Sinceri, ABC News for Rick. Are you talking about changing the way it's applied, or when you talk about too much handling, I'm still not quite sure I understand what you're talking about.
In the normal course of building a tank in the past, the power ramp, the protuberance airload ramp, was the last piece put on, and there was no traffic, no workers accessing that, kneeling on it. They used mats. I should back up. When we decided to do the rework for return to flight, there were a lot of improvements that needed to be made in different areas, and that required additional work beyond what was the normal processing flow. And so what had happened was they needed access to that area, and so they would put down mats, and workers would work around that on the power ramp, and it wasn't really appreciated whether or not that could have contributed to the foam loss. So now we have plans to try to nail that down.
Reggie Key from KHOU. You talked about a better tile that you'd like to see replace some of these tiles that are especially at risk, and and how it wouldn't be possible to replace all the tiles at once. If that is such a risk, why not just take them all off and replace them with the new ones before you go back up again?
Well, let me see if I can address that. First of all, there's a limited production of this new tile. You can't make a lot, and you make some, and the production rate is not such that we can make a 20,000 tile in the next couple of months. Secondly, installation of the tile is very labor intensive and time consuming. So even if you had them all ready to go, we don't have the number of folks, nor could they crowd in around the vehicle to put the tile on. If you'll remember, before the first shuttle flight, the original shuttle that we were going to fly, it was a 2.5-year process to apply all the tile to the underside of the orbiter, and that's basically what it would be for this new tile. But even more importantly, the new tile, by virtue of being tougher, like the foam, the tile is mostly air because that's insulating, and the fibrous structure, which gives it strength, actually works against the insulating property that you need for the thermal insulation. So there are some areas where putting this new tile on would not work because the tile in those areas need to be thin for aerodynamic purposes, and the new tile would actually allow too much heat to go through. So we're never going to replace all of the tile on the orbiter. What we're looking toward is the critical areas around the main landing gear door openings, for example, and other critical areas on the bottom of the orbiter, replacing tile in those areas so that if those areas get struck, they will be more protected.
Okay, let's go to the Kennedy Space Center in Florida next for questions.
Yes, this is Marcia Dunn of the Associated Press for Mr. Gilbrick. Regarding the foam loss being caused by damage by workers, is that an absolute certainty in your mind, or is that a most likely cause? And I'm just wondering if it's based on any hard evidence, or is it all supposition, and how you think that it can best be avoided in the future?
Well, we don't know for sure that it was the cause. We know it could have been a potential contributor. So to answer your first question, no, that's what some of this testing is intended to find. And again, we don't think in and of itself crushed foam alone could have been the cause of the foam coming off. We believe it was potentially a combination of that, a combination of the old spray process that had these knit lines and some features there that are not present now with the enhanced sprays. And also there are some issues that we're investigating with the underlying foam. This protuberance airload ramp is actually sprayed on about an inch of what we call acreage foam. And so there's mismatches in what's called the coefficient of thermal expansion. When it chills down, those shrink at different rates, and that creates stresses. And that potentially could crack that foam underneath the power ramp. So again, we have testing to investigate that potential root cause. So it's basically we're attacking all fronts and trying to learn as much as we can, but I don't know that we'll ever pinpoint one of those potentials as the root cause.
And I would just amplify, I think it's really wrong to try to pick out one potential root cause and say that's the underlying problem or that's the smoking gun in this sense. As Rick described earlier, foam is very complicated. The failure mechanism is likely some combination of the things that Rick's described to you, and it's really wrong to try to pick out one and then try to focus all your efforts on that. That will actually set you up for more problems in the future. You really need to have an approach that addresses all the potential areas, and we've got an approach by a new spray technique, limiting access to this area, investigating and analyzing the underlying foam that covers each one of those potential contributors. So when we reapply this ramp, it'll be a better ramp than we've applied before, addressing each one of those potential contributors. But it is really wrong to try to pick out. I know your tendency is you want to pick one thing, but you cannot do that in this case.
This is Chris Kreidler from Florida today. I hope you can hear me. My question is, I know that you're still evaluating your schedules, but when do you think that the foam from, when do you think that the new tank will be shipped to Kennedy Space Center? And will it be a different tank, a new tank? Do you have to kind of start over because of these potential issues with old foam and new foam?
Chris, let me address that one if I could. We are looking at ET-119, which, as you know, was at the Kennedy Space Center, was shipped back to Michoud just a couple of weeks ago. That is slated to be our first return to flight STS-121 tank. That tank, we have to do a number of things too. At the minimum, removing and replacing the PAL ramps, reworking the iPod closeout area where we think the wire may have actually allowed cryogenic ingestion of air to condense in an area. We have a number of things that we've got to do before we're ready to do that work. That tank right now is at Michoud, undergoing non-destructive evaluation, which amounts to be an X-ray in the foam areas, and then its protuberance air load ramp, the PAL ramp, will be dissected and looked at very carefully for what we can learn from that. So we do plan to use that tank for our first tank, and there's a discussion of what tank would be then the second tank, which we would want to have in readiness for a potential rescue flight, as you remember our strategy on that. That decision is yet ahead of us.
Hi, I'm Mark Kirkman with Interspace News. This question is basically about instrumentation and data. On 114, you had instrumentation on the forward power ramp, and I guess you were surprised by some of that data. I wanted to know if that means that either reducing the thickness of the power ramps or taking them off altogether, or if that's completely off the table, and what kind of instrumentation will you have on this upcoming flight? And one other thing with the graph you showed, Mr. Hale, I noticed a spike. You got like 6 tracks right at staging. Does staging tell you anything about the nature of the debris loss? Thank you.
Thanks. There are some expected things that we expect to see show up in the radar at SRB staging. If you think about the booster separation motors, the aft ones, which clearly don't point at the orbiter or the tank, those have covers, and you expect to see those kind of things show up on the radar track at SRB staging. So some things that we saw in the radar were expected and not a surprise. We did not, in the unexpected category, see anything right around solid rocket booster separation out of the ordinary. A couple of the spikes that you saw were clearly things that happened shortly after, in the 10 to 20 seconds after SRB separation, and those were things, principally the large loss off the PAL ramp that we already knew about. But the part of this that I find much more interesting is the fact that much of the popcorn and smaller stuff does come off later, which gives you an opportunity to while we want to address that and work on it later, gives you an opportunity to say that's not something you have to do for the first flight back. Regarding the instrumentation, the protuberance airload ramp, a piece of foam that's, let's see, 20 feet long on the forward part of the oxygen tank and 40 feet long on the aft part of the hydrogen tank. Did I get those numbers right?
15 and 30.
15 and 30, okay, well, keep me honest. Those pieces of foam are there to act in simple terms as a wind deflector. As we go supersonic, the shock waves move across the external tank, and we have other vital equipment that runs on the outside of the external tank. A cable tray that carries the wires that provide electrical functions for sensors, for valves, and that sort of thing. There's a cable tray that runs along the outside of the tank. There's the large 17-inch diameter liquid oxygen pipe that carries liquid oxygen from the forward part of the external tank where the liquid oxygen is back to the aft where the main engines and the orbiter are. And also two pressurization lines, one for hydrogen, one for oxygen, because those tanks have to be repressurized during flight. Those hard structures can be excited by these aerodynamic shock waves, and when I say excited, that's a good technical term. You don't want them to vibrate so much that they come off, to put it in simple terms. The protuberance airload ramp is to deflect the wind, the shock waves away from those hard structures and make sure they don't start vibrating in such a way that could cause structural damage to occur because they're vital. We put some accelerometers inside the cable tray at some points. We saw some information up in the forward end of the cable tray that did not match what we thought we would see based on the wind tunnel tests. So we are going back in the next tank to add more accelerometers. That, in fact, was a topic we talked about yesterday at the program board, into the cable tray. So we'll get more information with the eventual goal to say the combination of in-flight instrumentation telling us what is happening to the tank in flight with the amp on it, combined with wind tunnel testing and computational fluid dynamics work done on the computer, could eventually lead us to a point where we may decide that the PAL ramp is not necessary. The PAL ramp was put on, frankly, in the early stages of the program because the aerodynamics was not well understood as a safety measure. Again, it's a good thing to do, but if we find out that it's not required, or perhaps a much smaller ramp is required, and eliminate some of the foam off the outside of the tank, then you have eliminated something that can cause you problems, as we've seen. So the goal remains to do this investigation with the intention of potentially eliminating the PAL ramp in the future. But it's going to take us a couple flights and about a year worth of wind tunnel testing to come to a conclusion as to whether or not we can do that.
Hi, it's Bill Horowitz, CBS News. Thanks for Wayne again. You mentioned the cryo-ingestion, I guess, up by the bipod, and you've mentioned possible factors involved in the PAL ramp. Could you touch on the other, I guess, 3 areas where foam came off and what your probable cause scenarios are there? And related to that, can you give us a sense of why you have optimism about the May window, given that from what it sounds like you still really don't have a firm handle on why it came off or anything definitive on these areas. So what gives you that confidence?
Well, Bill, I wouldn't be quite as gloomy as you posed the question there. I think that we have done enough analytical work to lay out a series of tests that over the next couple of months are going to give us a very clear and convincing understanding of why we lost the foam that we did on the external tank, and allow us to design new techniques that will allow us to reapply foam in areas in such a way that it won't come off, even from some of these very complex interconnected causes. So we're addressing all of those. What has taken us from July until October, if you want to think about it, is to come to that level of understanding of the work that's got to go forward to provide an engineering, rigorous understanding of the causes and solutions to foam coming off. So what I'm here to report, what we're all here to report, I think, is a great deal of progress and a sense of optimism that we do have an understanding of the work that lies ahead of us. Otherwise, we wouldn't even be talking about a tentative kind of schedule at this time. The other three areas that we looked at, repairs in the acreage foam, we've got a number of tests that are going forward. You know, as we get damage occasionally in the large areas of acreage foam. There's some standard repairs that we do there. We have some theories and some understanding of how that might contribute to foam loss, and there is a number of tests going forward that in the next few weeks I think will bring us to more definitive understanding of that. Similarly, we look at some of the losses and what we call the ice frost ramps, which cover the brackets that hold those pressurization lines and cable trays to the outside of the vehicle. We are doing some tests with how that foam is applied, how it reacts under certain circumstances to the flight environment. There is a potential that all we have to do is vent that foam with drilling little holes in it as we do in the intertank region to prevent large foam losses from coming off. We think we're very close to coming to a definitive understanding of that set of foam and making sure that we don't lose any pieces in the critical time frame or any large pieces at least. So I think we have a great deal of optimism. Now, I left out one of the foam areas, intertank flange. Rick, you want to, I've talked enough. This is your topic. You should answer this. So why don't I turn it over and let you
yeah, there's a number of potential root causes that are being investigated. One was they had to go in and remove sections of the foam to go in and rework the intertank flange joint for the STS-114 flight. And there's a potential that there may have been undetected knife cuts as they were removing that foam, and so there's a test program and a detailed set of inspections that will be applied to any tank that's reworked in the future. And then and there's also some thermal modeling going on to determine if it was a void that what we call had a delta P event where the trapped air inside just had enough pressure to pop a piece of foam off as the external pressure and ascent dropped. So there's several avenues in work there to try to understand and correct that issue.
And one thing I'd like to add again is that, you know, Wayne kind of described to you the detailed schedule planning that's gone behind this. The teams have spent a tremendous amount of time of, first of all, working with the ET Tiger team, identifying what tests we think need to be done before we're ready to go fly. So they've laid out on a schedule where all those tests fit and where they all flow together. We've looked at all the analysis that needs to be done. We've looked at how long it takes to do these dissections of the PAL ramp. When Wayne talked about looking for voids in the PAL ramp, we're going to cut every 1/8 of an inch along the PAL ramp, along those 40-foot sections, to look for void distributions inside those PAL ramps, and then take that void distribution information into a math model to go look at potential foam losses. So they've laid out detailed, intricate schedules that all lay out, support all the work, support all the tests, support all the analysis, and it gets us in the May time frame. So they have done a tremendous amount of work, everything possible to lay all this out and identify this work. So it sounds like we haven't done a lot in the past couple months. The teams have done a tremendous amount of work of putting together a very definitive schedule that now will be trackable for Wayne and his team as they go through and make sure each one of these tests, each one of these milestones and analysis that are occurring when we planned, and also the results of those then flow into other subsequent activities downstream. So I can't stress how much I'm pleased with the planning effort that's gone together from where we are to go forward to set this kind of May time frame of where we are.
Okay, up the East Coast to NASA headquarters in Washington for questions, please.
Just talk. Brian Berger with Space News for Wayne Hale. With 500 people back on the job at Michoud, what fraction of the workforce does that constitute? And do you know when Michoud might be back to full strength?
Yes, let me answer both of those, Brian. That's about 1/4 of the workforce, roughly, back at work today. And that will ramp up to a full workforce being back in the plant around the 1st of December. So they are working very hard. Again, I have to emphasize to you that it depends very much on the infrastructure work that's going on. We are, as interesting as it may seem, critically dependent on the repairs to the Interstate 10 bridge that leads up to Slidell and those parts of eastern Louisiana and Mississippi where a large number of our workers live. And we're tracking quite closely some of those infrastructure repairs that are going forward to allow us to get the full workforce back on site.
Tracy Watson, USA Today, I guess for Rick Gilbert. Can you talk a little more about the knit line problem that you saw with the PAL ramp and how it was decided before the flight that it was okay to fly that ramp as is versus the problems you're discovering with it now?
Sure thing. Yeah, they had 62 flights, I believe, with imagery prior to this flight. It was part of that decision with no known loss of PAL material. So they had a very strong flight rationale backing them up. But they also had developed these non-destructive evaluation techniques and had applied those to the fly as is foam. And nothing in those indications showed any voids or features at the time that were thought to be anything of a highlighted issue. And so that basically fed into that decision, and the dissection data that were done on the enhanced sprays at that time basically were a wash. There, the number of voids per linear foot and the size of the void, critical dimension of the voids, were basically the same. So the enhanced sprays, they did learn that there are several things they can do that can minimize those knit lines and thereby eliminate that as a potential contributor. Again, we don't know if it certainly, for sure, if it is a contributor, you can minimize that. And so part of the enhanced process was to, they changed the guns that the sprayers used. They gave them a lot of ergonomic improvements, a lot of human factors improvements. They've got spotters now that watch the sprayers as they put the PAL ramps on. They video it and they review that afterwards. So a number of techniques that are all aimed at improving the quality of that PAL ramp spray.
And let me add just a little bit of that, if I could, Tracy. What I think you've heard is that we addressed the principal causes, single causes that we thought prior to STS-114 were resulting in foam loss, and that is what we call voids, little holes that are residual in the foam. And it was pretty clear that the enhanced spray techniques for the PAL ramp, not for other areas, but for the PAL ramp, were not markedly improved over the old sprays. That's what we were talking about, Rick was talking about with the X-ray techniques, the non-destructive evaluation techniques. We talked about knit lines, and we knew that there are more knit lines and some of these low-density foam features in the old PAL ramps than there are in the new improved PAL ramps, but our testing indicated that by itself would not cause foam loss, and that's why we talk about a combination of events, perhaps crushed foam which is not detectable by the existing NDE techniques, perhaps collateral or should I say work-induced damage in the area, perhaps thermal expansion and contraction leading to airline cracks in the underlying foam, which any one of these by themselves were not thought to be single reasons to cause foam loss. Now we apparently have a collection of things that can contribute to foam loss if they occur together in the same place at the same time. So in retrospect, looking at what we knew then, I stand by the decision that the program made collectively. But we are smarter today than we were 9 months or a year ago. We have this flight experience behind us. We have new information that we've learned. That's part of the culture change, I think, inside NASA in the shuttle program that we've become a learning organization, and we're looking for new facts, and we're always continually trying to improve our operation based on what we've learned. So I don't look at this in a bad light. I look at it as a learning experience, and we have more information and better knowledge than we had been, and we can make a better decision now.
Yes, hi, Guy Guglielmo from the Washington Post, I think probably for Rick. But from what I'm hearing here, what you're talking about now is not fixing any design flaws, but preparing for this next flight by changing techniques. Could you just confirm, or are you going to redesign any aspects of the power ramp, or are you just basically going to try to do the job better?
Well, most of the work of making that power ramp spray better has been done. That was part of that forward 10 feet that was resprayed for this last flight and would be part of any tank that's already been assembled in the future. So we, of course, always want to continue to try to improve, and that's one of our recommendations, that the project continues to try to find ways to make the sprays better. But we see a drastic improvement in the quality and the lack of voids and other features in the improved spray. So I guess that answer would be that they'll continue to, but we feel like they have an adequate spray now to go back in and start applying the power ramps to these next tanks.
And we might address the bipod area. In the bipod area, we have a mechanism where liquid nitrogen can potentially flow down the center of an insulated wire underneath the insulation. We're going to make a design change there to essentially plug that path. So I think going back to your question, some of its process change has been applied to the power ramp, but then there's a design change underlying in the bipod area where we're going to essentially stop a phenomenon that allows the cold liquid nitrogen to get into an area and freeze and then potentially cause the foam loss we saw in the bipod area.
Hi, David Kestenbaum with National Public Radio, I guess for Bill. Could you talk about the decision to essentially cancel a third of the shuttle flights to the space station, and those were originally seen as essential, so what's not going to happen as a result of that? And why was the decision made?
Again, we kind of looked overall at our ability to launch the 28 flights that we've been talking about to space station, and we look at the decision essentially to cease flying the shuttle on September 30th, 2010, and there was no way that we could accommodate those 28 flights in the time between now and that September 30th date. So we went back and we looked carefully at what we thought we needed, and we looked also what was available or achievable from the shuttle side, and we came up with the current numbers we talked about, the 18 flights to station. And that discussion, 18 flights to station plus 1 for Hubble for a total of 19. When we look at that, what occurred was we dropped the centrifuge accommodation module flight from the manifest. We had a Russian solar power module flight that was actually slightly more than one flight, about 1 1/3 shuttle flights, dropped that from the sequence. And then we looked at our manifesting projections of what we needed in terms of logistics and spares and looked to see if we could cut some flights from that. We also looked a little bit at our science inventory. Was there a way there that we could essentially repackage some of the science and remove things back? So when we looked at it, we came up with this scenario that we end up now with the 18 flights. It looks like we end up with a very sustainable station that will be have enough spares on board that when the shuttle retires, we'll be able to support the station in a good manner for several years until CEV comes online in 2012, and then followed by some other commercial carriers potentially even before that. Maybe we might pick up some additional commercial carriers in 2009, 2010, which will also help with the maintenance burden. So basically, we cut several pieces of equipment that we would like to fly out of the manifest, but we think there's other ways to accommodate those. So for example, on the Russian power module, we can provide power from the U.S. solar arrays to them and still make up for that loss. So we cut things that we didn't like to cut, but in the sense of where we are and the number of flights we had that we cut, and we still have a very viable station with the 18 flights.
Back here for two final questions, Mark and then Gina.
Mark Carreau from the Houston Chronicle for Bill Gerstenmaier. What's the policy on keeping an American among the crew on the space station? Is that going to be a lock, even with some uncertainty at this point about how crew will be transferred?
Again, I guess if we look forward to where we are next spring, as we've described many times, we need some relief in the Iran Non-Proliferation Act. Congress is working that as fast as they can. I think there's some bills in both the Senate and the House that are being worked, and we need some resolution of that to keep our crew presence on board the station. So we're looking to Congress to work that and resolve that in the proper time frame, and we'll see where we are in the spring.
And Gina.
Gina Sinceri, ABC News for Bill. I've been in a hurricane fog for a few weeks. So is the mission to Hubble, has that been decided that that mission will be flown? Have I missed something?
Again, the Goddard personnel are starting planning for that mission, and they've been working on that in a lot of detail. We still would like to fly STS-121 and get that behind us and gain that experience before we officially commit that to be a flight, but we're doing all the preparatory work to enable the Hubble Space Telescope mission, and we'll be prepared to support that after we gain some data and understanding on how well these fixes and how well our instrumentation systems work on 121.
Okay, that's all the time we have. I want to thank you, gentlemen, and thanks everybody for joining us today, and have a great weekend. Thanks. Well, good afternoon, everybody, and welcome to NASA's Johnson Space Center here in Houston. Welcome you to a Space Shuttle program update on all the activities ongoing around the agency associated with the Space Shuttle. I'll introduce the participants, and of course, and then we'll have discussion with them, and then with the Q&A session after that. To my right is Wayne Hale. He is the manager of the Space Shuttle program. To his right is Steve Polis. He is the manager of the Orbiter Projects Office here at the Johnson Space Center. And to his right, joining us from the Marshall Space Flight Center in Huntsville, is John Chapman. He is the manager of the External Tank Project. We'll hear from all three, and then we'll throw it open for questions. With that, I'll turn it over to Wayne.
Thank you, Kyle. It's good to be here, and it's good to have the opportunity to bring everybody up to speed. We've been several weeks since we've chatted about progress in the Space Shuttle program, and there have been a number of interesting developments we'd like to talk about a little bit today and answer questions. First of all, you know, we went through really two serious hurricanes in the Gulf Coast region. One of the critical things that we're trying to do is get ready to repair external tanks and provide them back to the Kennedy Space Center for flight operations. And the people of New Orleans, and in particular our plant that manufactures the external tanks, which is on the east side of New Orleans, Michoud, have gone through some really horrific times. I had the opportunity this past week to visit the area, to take a look at our plant, which is in remarkably good shape, but even more important, to visit with the folks that are there that work for us. And they had some just incredible stories of bravery and resilience under adverse circumstances that are just almost heartrending. And then they are back at work in this highly skilled, very technical plant, doing incredibly precise work, even in the face of difficult personal situations. So my hat is off to the people that work down at Michoud on the tanks. We did, in fact, lose some time in our resolution of the foam loss problem. The estimates are anywhere from 1 to 3 months of lost time in resolving the situation that we had in our test flight on STS-114. You know, we lost several areas of foam, one of which that was quite unexpected was a fairly large piece off the protuberance air load ramp, the PAL ramp as we like to talk about it. Our investigation has been very extensive. John Chapman is going to talk to you quite a bit about that. We are continuing with that investigation. We have had an interesting finding in the last few weeks of some indications on the radiography of the potential of some small hairline cracks in that foam ramp. That's an interesting observation. We are trying to come to grips with what does that mean, whether it's a significant find or not. We're also trying to do ground proof of the radiography by actually dissecting those ramps apart. We're going to show you some of that video here in just a few minutes. We are pursuing a three-pronged approach on PAL ramps. The first approach would be to provide a new and improved manual reapplication. We're removing all of the old ramps off all of the tanks that were in production. So we have a process where we have an improved manual spray to replace those ramps. We are following that up with the potential to automate the spray. We have a robotic sprayer that is undergoing test and evaluation at the Michoud plant, which could potentially apply a more uniform layer of foam in this area. And finally, we're taking a look at the aerodynamics. In the long run, we have decided we would like to remove this fairly large piece of foam, just eliminate the hazard that it might cause. We think we have a very strong case to be ready to take that ramp off by the third flight tank. And some folks believe that we can accelerate that and potentially even remove it for the return to flight or STS-121 tank. So we're looking at those three approaches for the protuberance air load ramp as being our number one concern on the foam. The tank production and the resolution of this particular problem we had on 114 with the external tank foam is the pacing item for return to flight. When we talk about schedule progress, we have assessed the schedule and all the elements can support launch in the May window, but we have not set that as a flight date. We have rather set our schedules to work toward that date in the sense that we want to have the crew trained, we want to have the orbiters processed, we want to have everything ready to go, but we are depending on the resolution of the external tank investigation and the reapplication of that foam, if that's what we decide to do, as the pacing item. In other words, the technical progress is going to drive the schedule, not the other way around. We're committed to doing this safely, returning to flight as soon as it's practical to do so, but in a safe manner. Next to me is Steve Polis, who's going to talk to you a little bit about some of the interesting things we're doing with the Space Shuttle Orbiter, the gap fillers that everyone was quite interested in. He's got a fascinating story to tell, and from the program manager's standpoint, it's interesting because we can do this work and have the Space Shuttle Orbiters ready to go fly and not being the constraining item. Again, our pacing item is going to be the tank. So with that having been said, I'm going to turn it over to Steve and then to John, who will give you a little bit more detail, and after that we'll have questions.
Okay, thank you very much, Wayne. I'm going to knock on wood. Since he's saying right now the orbiter is not the pacing item, let's hope that stays the case. I'm going to talk three technical issues or items of interest today. First off will be the RCC post-flight inspections that we perform, the reinforced carbon-carbon on the wing leading edge and the nose cap. Talk a little bit about the blanket anomaly that we saw on orbit, and then what ultimately happened after we returned from orbit back to the ground and what we found. And then lastly, the gap fillers themselves and what we've identified as the root cause for that problem and what we're doing to eliminate it. Before I get into the technical items, though, I just thought I'd mention, because I think some folks have heard, on a monthly basis, the orbiter team, and the orbiter team includes not only the design center, the folks here at the Johnson Space Center and at Huntington Beach and at the Kennedy Space Center as well, but also our operations team members, those folks that actually process the vehicles. Every month we get together and we look at what's going on with each of the three vehicles. Of course, now that OB-105 Endeavor has come out of its maintenance period, we have all three vehicles up mission processing. So we're evaluating the content of the work, the priorities of the work, the risks associated with the different issues that we're currently working our way through. We're making sure we have the right engineering in place and the right understanding of the requirements. So it's an outstanding interchange between ourselves and our ground ops counterparts. It helps us all ensure we're doing the priorities in the right order. And if we have any disconnects, we bring that forward to program management for their consideration. Last week on Tuesday, we completed another summit, talked all three vehicles, and from my perspective, everything is going extremely well. All three vehicles are processing on schedule, no major anomalies or issues or concerns that would keep us from meeting our current program goals for the launch windows that we're looking at. So that happens, as I say, monthly. Now, to get into the technical items of interest, which I think most folks would like to know where we stand, first I'm going to talk about the RCC, the Reinforced Carbon-Carbon Inspections post-flight. You may recall that we agreed coming out of the CABE, the Columbia Accident Investigation Board, that we would do a post-flight inspection on our reinforced carbon-carbon. We have chosen to use thermography as our primary inspection tool, and we also use radiography or x-rays or ultrasound or eddy current if we find something of interest that we want to get a little further detail on. So we can bring up the first slide. What you're seeing here is really to show you the thermography photos and try and discern a particular area of interest. I don't think would be of real benefit. But what you can see is this is a T-seal. It's the right hand T-seal number 5 between panels 5 and 6. And you can see the small circle area there, area of interest. This particular item was identified in the thermography that we did on the bench prior to flight. Prior to STS-114, we're seeing essentially the same indication post-flight, but we want to basically compare them, overlapping them, if you will, to make sure there was no change in the geometry pre-flight to post-flight. We have our stress analysts that are engaged as we speak, and the preliminary assessment at this point indicates that in the likely area of interest is perhaps a void in the, you may recall we have 19 plies of layup of the carbon laminate or the composite itself. There could be a void or slight delamination internal to the panel itself. So our analysts will go off and verify that we have adequate strength to be able to accommodate the loading through the entire mission profile. This one is not one that I'd say we're very concerned about. We just need to dot the I's and cross the T's. Next shot. This is panel 8R, right-hand side, and this is where I'm going to characterize this truly as a success story. We have seen in the past, and I probably should mention, we have about a 20,000th inch coating on the outside that's essentially a ceramic glass. That material is porous, and the atomic oxygen in low Earth orbit will permeate that coating, and eventually it will start to oxidize between the coating itself and the carbon, the panel layup. When that happens, you start to get to the point where you have a separation between the coating and the panel. Now, historically, the way we verified that we didn't have a problem with our panels is by technicians doing tap tests, literally putting their hands on the panels and verifying that there was no flexure, if you will, in the coating. And that's how we started to pick up that we would see a concern relative to the coating, and then we'd ship that panel back to our supplier, and we'd go ahead and do the repair, and we'd be ready to go fly again. Well, now with our new and improved capabilities, in particular our thermography system, we're starting to see the beginnings of craze cracking, if you will, basically a spider web type cracking of the backside of the coating, between the coating itself and the carbon. So this is an early indication that we're seeing that separation, the atomic oxygen starting to eat away and cause that separation between the coating and the panel. So now we can send this back to the vendor and get it repaired long before we have any real concerns about the coating starting to separate and perhaps eventually coming off. So again, very much a success story. Next shot is of panel T-seal on panel 6, between 6 and 7, left side. And this particular area of interest is not one that we saw pre-flight, but it is one that we are seeing now in the thermography itself. Some of the other NDE techniques that we're utilizing are not showing us this particular, again, whatever it may be, a void or a subset of delamination internal to the T-seal itself, but it is very small, and the stress analysts from the preliminary perspective say it's not going to affect our capability to go fly. We'll finish the stress analysis in about a week or so, and be able to say that we're good to go ahead and fly with the configuration that we have. So post-flight inspection has been very important. As I say, we're starting to learn things as we're using our new tools, and the panel 8 verification and seeing that we've had some coding loss separation there is really going to be a benefit for the long term. So moving away from the carbon-carbon, I'm going to get next to the blanket. We'll show the first shot here. Many of you recall from the mission, we had just below the commander's window a blanket that had billowed. So we had some concerns about our ability to re-enter under that configuration. If we go to the next shot, you can see this is what the blanket looked like upon landing out at California. And then as we were working our way through the mission management team, we realized that a good way to go ahead and prove to ourselves that we were going to have a good configuration to re-enter with was to go do a wind tunnel test. So we sent our experts out to Ames, and we can go to the next shot. And what we had our team do was try and emulate the configuration below the commander's window from a geometry perspective. Had our experts take all the photography that was provided between the boom, orbiter boom sensor system, and the digital cameras out of space station, and what we picked up from the shuttle remote manipulator system, all that photography, and they went in and they tried to create the damage to the greatest extent possible, consistent with what we saw on orbit. So then we put that configuration into the wind tunnel, and in that next shot shows the final results of that testing. And if you do a comparison between this test article and the actual flight article itself, they're essentially identical for all intents and purposes. So it really ended up being a good test, and in the actual, obviously, proof in the pudding is when we landed the vehicle and we saw that the damage was essentially the same. Now, the root cause for this particular anomaly ended up being some stitching that had broken away, and what we have done from that point forward now has gone off. We've inspected 486 blankets on both 103 Discovery and Orbiter Vehicle 104 Atlantis. On each of those vehicles, we have a subset that are going to require replacement. There will be 40 on 103 and 60 approximate numbers on 104 that will need to be removed and replaced. But we do understand the concern with the amount of stitching that we have in the areas that may be broken, and we've identified those that do need to be removed and replaced. So we're in good shape, and the time to accomplish that, we've got that well in hand, and don't see that as a scheduled driver. The last item that I'm going to talk about, and I don't have any photography, I've got a little show and tell. This is actually one of the 2 gap fillers that was removed off of Discovery during STS 114. And the item of note here is the adhesive we use to bond these gap fillers to the vehicle, and their structure down here below on the bottom part is an RTV. And really what we would want to see on this is not this smearing of RTV up along the side. We want to see the bond line just at the base so that it's attaching the structure. Through our root cause analysis, what we found is as you smear this RTV and it starts to attach itself to one of the tiles that it's in between, the tile is a good insulator. It's obviously protecting the vehicle from the heat of reentry. However, it does conduct heat, and as it does so, whenever you have an adhesive along the side of the tile, it starts to weaken because you are starting to transfer some heat. And as it weakens on the side, if you did not have a good bond at the base, that's when you have the opportunity for the gap filler to separate. So that's exactly what we found out. And what we have done now is we have a set of procedures in place that ensures that we do not have any attachment between the side of the gap filler and the towel itself. We have a good bond line verification now to where instead of doing roughly an 8-ounce pull test in 3 different locations along this particular gap filler, which happens to be about 6 inches, we actually do a 5-pound pull test. So what's that, 10 times order of magnitude greater pull test to ensure that we have a proper bond. We just completed our certification of this new process, and of the 80 test points that we did, and this is with different technicians and quality inspectors, we only had one that failed that 5-pound pull test. So obviously we went back in and rebonded and verified we had a proper bond. But we just started on the vehicle last week. The procedures have been released. We are installing new gap fillers literally as we speak. And at this point in time, we have put the vehicle into 3 primary zones, and we're going to work them in priority order. At the front of the vehicle, from the tip to just behind the nose landing gear door and slightly along the sides of the orbiter, if we trip the boundary layer from a reentry perspective and started to cause extra heating from the turbulent flow, we were concerned first and foremost about the reinforced carbon-carbon. So we wanted to make sure that we didn't over-temp the reinforced carbon-carbon. So that's the area we're working on first, where a protruding gap filler would affect the wing leading edges. And then our next zone is going to go basically down the fuselage of the vehicle itself. And in this case, we're trying to minimize any concerns for the elevon cove region back in the vehicle or the body flap area. And then our last area, or zone 3, is going to be on the wings, port and starboard. So we have that worked out, well defined in a process procedure for our Kennedy operations teammates. And I think within about a month we'll have a pretty good feel with how much of all of that we're going to be able to get done prior to our next launch. But as a minimum, we certainly intend to get the Zone 1 area complete, which will cover us from the reinforced carbon-carbon perspective. And that's all I have, so I'd like to turn it over to John Chapman, our ET Project Manager.
Okay, thanks, Steve. As Wayne said, starting off this briefing, all the team, the ET team particularly, has been hard at work over the last few months. The hurricane has sort of gotten in our way a little bit, but we're pressing on with that. And with each day, we're learning more and getting smarter about the Discovery foam losses and what happened there and what we can do about it. Today, I'd like to discuss with you 2 principal areas. First would be the investigative activity that we have going on, and also the testing and analytical work that goes along with that to support that activity. And then following that, to talk to you about process development and design enhancement activity that we have going on with the tank to improve our design and to ensure that the things that happened the last time don't happen again. So in the first item, the independent in-flight anomaly, or IFA team, that was established in Huntsville, led by Dr. Corky Clinton, they are in the process of working through their very extensive fault tree, some almost 500 blocks of that fault tree, and the purpose of the fault tree is to determine the root cause of the foam loss and identify that back to the project. They are approximately 75% complete in terms of closure of those blocks of that fault tree by the sub-teams. And the way they're set up, they have a senior board that the sub-teams present to, and the senior board checks and verifies that the closure rationale is correct for each one of those blocks and then signs it off. And the senior board has gotten to about 65% of those blocks on that fault tree. The remaining 25% in the overall fault tree that have not been completed yet, those are primarily open because they're hinging on test and or analysis to be completed. Our test program is ongoing. We are currently well into the fabrication of our high-fidelity mock-ups and test articles that we use to support this test series, and that is currently on schedule. Our thermal vacuum testing and our cryogenic testing is also ongoing. Wayne mentioned in his opening remarks one of the events that has occurred in the last week or so here in the external tank world is the discovery of some cracks in the protuberance airload ramps
specifically the liquid hydrogen ramp, which if I can point to this on the model here, this would be the liquid hydrogen ramp right here. And we've discovered some 9 small cracks, 2 of which are visible on the surface. Those that are not visible on the surface have been examined with non-destructive evaluation techniques. We have several interesting newly developed techniques that have been developed since the Columbia accident for application to foam. I do want to point out that ET-120 is a tank that we are, in the technical world, very interested in looking at, because it has undergone 2 thermal cycles. It's been filled up with cryogenics twice before it was removed from the stack and sent back to the Michoud assembly facility. So it represents the very first time that we've had, in essence, a tanked article that has seen cryogenic cycling, that we can now utilize these new non-destructive evaluation techniques on to examine. And it's also the first time that we've been able to even visually examine it this closely. So as I said, we've found 9 crack-like indications, 2 of which are visible on the surface. And when I say visible, they're just barely visible on the surface. These are very small. We're in the process of dissecting those PAL ramps, and the term dissection in this vernacular means cutting the foam into little pieces so that we can get a good view of the cross-section of that to see what they look like. It's obvious that no crack is inconsequential in the business that we're in, but we're still examining that to find out what causes these cracks. Are they indeed detrimental? We don't know that they're detrimental right now. And how can we possibly prevent them? So that's part of the ongoing work that we've got going on. If you can roll the video, we've got a videotape that shows dissecting going on ET-123. This is specifically a liquid hydrogen protuberance air load ramp. And what you see here is the technicians at Michoud using some specialized tools. In some cases, you'll see small saws that are used to cut the foam. You'll see some plexiglass back plates that are used to protect the foam so that it doesn't, the process of slicing off the ramp, it doesn't damage anything else. When we cut the ramp off, we leave about 1 inch of foam at the base of the ramp so that we don't harm the subsurface foam that's underneath it, the acreage foam that's overall in the tank. Then we proceed to sand that remaining layer down until we get right down to the basic sprayed-on robotically applied foam. There you see removing the back end of the piece of a PAL ramp there. And then that will be subjected to NDE itself. That's non-destructive evaluation again. And then it'll be sliced into very thin slices, almost like a cheese slicer type that you would do, although we do it with small knives, to examine the cross-section of the parts. There you see the technician installing a plexiglass guide that allows us to saw without cutting things we don't want to cut. This particular activity that they're going through right there is to cut the initial part out where we want to lower the saw down in and then go horizontally there. So you've got to cut a large enough part off to be able to get the saw in. So those are the type of things. It gives you an idea of the size of the tank that we deal with as we do this activity. With all of the testing that we've done so far, and we're only part way into it, we expect to complete our testing, by the way, in between mid-December and mid-January. We haven't found any eureka or smoking gun
so far. Certainly the cracks that we found in the PAL ramp is interesting, but we're still in the process of understanding what that means. So I wouldn't consider that a eureka or a smoking gun at all at this point. That's part of the analytical work. In our test program, it's best characterized as a series of small steps that we then assemble into the whole puzzle to see what it's telling us. So that's where we are on our test program. I would like to now address the topic of work-induced damage. That's been a topic that was discussed at the last one of these press addresses. And that is where we are looking at reviewing all the repairs on the tanks that we're contemplating flying right now to see have those repairs been made properly, what caused there to be a repair to the foam in a certain area, was there damage to the foam, what happened there. As part of that, we are examining the sensitivity of our ability to detect areas of crushed foam or fractured foam to make sure that we can indeed see the things that we need to see. As a result of that testing and assessment, there's a possibility that we may alter our procedures based on the results. Also part of that testing is to test foam samples that will be subjected to varying degrees of damage by crushing, and to see what happens to those. When we subject them to flight-like environments, what happens to that? It could be that even crushed foam has no effect, but that's part of our test program. And finally, part of our test program is to, on work-induced damage, is to measure the actual forces that the foam is subjected to as technicians work on and around various parts of the tank. We put down mats that are large, thick polymeric material that protects the foam, the sprayed-on foam on the tank, and we have instrumented some of those mats and have actually measured the working loads that the foam would see, the tank foam down below it. And that'll all contribute to making sure that our process is correct and that we're not damaging things. And in fact, we are completing that before we get back on the tank to do any repairs or replacements in the future. Which brings me to my second area that I wanted to talk about, and that is process development and design enhancements. I mentioned mats, and we're in the process of replacing all of the mats that we use on the tank with new mats. Those mats are not just a single piece of polymeric foam, they also have a piece of hard plastic inside it that also helps to attenuate the load and spread it out over a greater area. We talked about PAL ramps a minute ago. We're well into the verification and validation of an enhanced spray process should we elect to replace the PAL ramps that we've got on the tank. The techniques that we would use for that PAL ramp replacement would be very similar to the techniques that we used on the front 10 feet of the PAL ramp, the hydrogen PAL ramp, which we did before Discovery's flight in the summer. That process of verification and validation involves a series of spraying on high-fidelity mock-ups and exactly the type of conditions that we have on the tank itself, and then dissecting those test sprays to verify that the procedure is producing the quality that we want from the foam. Process control is the secret to application of foam, and this is just part of making sure we have the process control right. And then as a final step throughout all of that is the certification of our sprayers. Wayne mentioned the hardships and the trauma that our workforce has gone through as a result of the hurricanes in New Orleans. And in fact, one of our sprayers, shortly after the hurricane hit, spent 3 days with his family on his rooftop awaiting helicopter out to dry land. So the perseverance of these folks and their dedication to the task to get back to work and make sure that we're making the best foam possible is absolutely incredible. The
The last thing I wanted to mention to you in the way of improved parts of the tank is the bipod heater cable enhancement. One of the areas where we lost foam on this last flight was in the vicinity of the bipod, and our investigation has shown that there's a potential for a phenomenon known as cryoingestion in that area, in which cryogenic liquid would be conveyed down through the open areas of the cable bundle. That would then be deposited down by the bipod area, where it could then cause a piece of foam to possibly come off. The fix that we've come up with for that is to seal the wire so that nothing can go down the cable bundle, and that process of sealing it, as well as the specific design of the sealing, is well underway and will be completed very shortly. It is safe to say that the closeout of the foam in this area by the bipod attach point is not going to change. We'll use the same verified and validated foam application procedure that we used before we returned to flight in the summer. So in summary, I'd like to say that the ET team is totally committed to returning the vehicle to flight and to correcting the foam issues that we found on Discovery's flight in the summer. I've only touched on a few of the items that we have in work right now, but I do want to say that all of our activities are in support of the correct launch date and not just one that would be dictated by schedule. So safety will not be compromised by any kind of schedule pressures. So that's it. Frank? I'd just like to point out, I think, the great change in attitude that's come through on the shuttle program. We are looking at things in much more depth, trying to make sure that we have identified all our problems early and solved them completely so that we can fly safely. I think the example that Steve Pullis gave of looking at the reinforced carbon-carbon panels in a much more in-depth way and identifying problems so much earlier that we not only prevent a safety problem, but actually allow ourselves to do a much less expensive preventative repair and return that panel to service early is just indicative of the way things are going. The thought that we have taken a full-size flight tank to the Kennedy Space Center, filled it up with liquid hydrogen, liquid oxygen, pressurized it, done that a couple of times, and then shipped it back to the manufacturing plant where they can look inside the foam with these new techniques is something that would never have even been considered in the early days of the program. We're just taking a lot more care with our vehicle to provide the level of safety that we need to. And sadly, experience has shown us that we have to take that level of care. So we are, I think, in good stead to proceed toward a launch next year, again being driven by the results of our technical folks and the output of the investigation and the capability to get our hardware into the safest possible configuration. And with that, I'm ready for questions.
Okay, we have 4 centers with us today. We'll start here and then go to the East Coast and out to the West Coast. We'll start with Mark.
Mark Carrera from Houston Chronicle for John Chapman. Could you kind of point to the place on the PAL ramp where you found these cracks? Why, though they're small, they may be a potential concern? It'd be great if you could describe the dimensions a little bit, and if you're using a fault tree analysis as well to find out where these cracks, how these cracks came about, where are you? I mean, where are you going? What direction are you headed in that process?
Well, Mark, the cracks that we found are in fact spread in places along the entire length of the ramp. It's principally from about the flange on down. And in terms of characterizing the size of them, right now it appears that they extend laterally across much of the ramp, but that's exactly why we're in the process of dissecting these right now. Our indications are, at this point, through non-destructive evaluation, and we're in the process of adding the dissection data to that as we excise each one of these cracks and then slice it apart and look at the depth and how far it goes. So in terms of the fault tree question that you asked, our independent in-flight anomaly investigation team that has their fault tree already, they are absolute key players in looking at these cracks and taking the results of those look-sees and feeding it into the fault trees that they have. So, and that activity is ongoing right now.
I just got a brief follow-up on that. I guess what I was wondering is there any way to separate whether that cracking occurred during the on-pad cryo testing that you did earlier this year or during manufacturing? And, you know, I guess you implied this, but is this something that could lead to the breaking away of foam that you hadn't suspected before?
Well, we did our non-destructive evaluation assessment of this tank before it was shipped. So we're very fortunate in this activity to have a before and after look-see added, so we can compare what happened and look at it from that perspective. In terms of the full implication of this, we're only partway into our assessment of this. So whether this means that these are detrimental or not, that's to be determined. That's exactly what our investigative folks are looking at right now. If I could just add a little bit to that, we're in a very fortunate place because we not only took the x-rays and so forth of this tank before we shipped it to the Cape, we actually had another tank that we did the same thing, shipped it to the tank. It did not undergo the launch pad environment. We didn't fill up with cryogenics. We sent both these tanks back to Michoud. We've looked at the tank that wasn't on the launch pad, didn't get filled and pressurized. It has no indications. And the tank that was out on the pad did. Now that's about as close to conclusive as you get in this business. It appears that the thermal cycle, the stretch or contraction of thermal cycle or pressurization, you know, is a factor here. Although the engineering reports haven't been done, we've got to get to the bottom of it. It does appear that that's a factor. Now, whether or not these particular little indications are significant and could cause the liberation of foam, that's what the testing's going to tell us over the next few weeks.
Yeah.
Hi, Tammy Stone, Associated Press. You said that the hurricanes cost you a few months. I guess can you explain why you still think that you'll be able to make that May launch, or you're still working towards that with kind of the few months that you've lost?
Well, when we talk about costing us time, it's a simple calculation based on people being out of the plant in Michoud. We looked at a period of time when there was literally no one working in the plant on tanks. We had to recover the facility. People could not get in and out. And then we went to another period of time where we weren't up to full strength in the facility. So when you calculate that all out, it's been basically the loss of between 1 and 3 months, depending on how you do the calculation of work in the factory at Michoud, which I think directly correlates to the amount of time that we lost in the investigation. For example, we could not ship the tanks back from the Kennedy Space Center to Michoud until they'd recovered the facility to a state where they could accept tanks and we had enough workers to work on them. So we couldn't even start doing these kind of x-rays until we got that workforce back online. So that's how we calculated the time lost. As to the future, we've assessed the plan forward, and if the testing comes in as we think it might, and we get our workforce back onto the tanks reapplying foam, if that's our decision, as we think it will be done, then clearly we have an opportunity for the spring. But again, the point is not what our schedule assessment is, it's how the work goes. And as we get the test results back, as we see how the work progresses, then we'll be in a position to set or to look to set a more firm schedule, not the other way around. We don't want the schedule to drive the work.
So that there, at this point, hasn't been kind of a eureka moment or a smoking gun. With that being the case, I mean, do you think you can get to the bottom of this? And if you don't, do you fly? Or?
Well, okay, there's two parts to that. Number one, I think we really do need to get to the bottom of it. Of course, you have to define where the bottom is. I think sometimes people say you have to ask why 7 times to get to the root. We're going to get to the practical solution to ensure that we don't lose large amounts of foam off the tank. That's clearly something that we've got to do to fly safely. And we think that we can accomplish that work, in the next few months. So that's where we're headed.
Okay, let's go to the Kennedy Space Center down in Florida. Questions there?
This is Jay Barkley with NBC. I'd like to address this to John Chapman. Mr. Chapman, I received an email from a retired project manager or a project engineer, rather, on the external tank, and I'd like to read to you what he wrote me. He says, focus on STS-1, which was the only mission flown with a white ET. Subsequent missions have been flown with an unpainted ET. Reason, it saved 800 pounds and related paint cost. The paint reduced the wind drag over the foam and sealed over the joints in the foam. The paint's own cohesive tensile properties help prevent the breaking off of foam debris, which is now graphically shown by the newly installed cameras. Considering advancements in coating since 1980, even higher strength coatings are available to encapsulate foam debris. It would be interesting to compare foam stacks from STS-1 with subsequent flights. Have you looked into this, or have you considered it?
Yes, Jay, we have. We've examined the possibility of coatings on the tank as a possible way of increasing the strength of the foam, and to date, our assessment of that is that it's more productive for us to improve the process that we use to apply the foam. And to make the foam as good as we can, therefore having the desirable strength that way rather than to put on a coating on the outside of it. But we certainly have evaluated that and looked at the potential of coating the foam. But the technical team that is charged with doing that decided that that was not the right approach to go.
We lost you there at the end, but I'd also like to ask Steve, we were talking about the gap fillers. I understand from the people here at KSC that that's the pacing thing for them now on the shuttle. What are you doing exactly? Are you checking every gap filler on Discovery, or just some here and there? What's your program?
The process is really, at the end of the day, we will check every gap filler on the vehicle. We have just prioritized how we're going to go tackle that problem and put it into 3 separate zones. As I touched on earlier, Zone 1 being the area that could influence or cause a higher heating effect on the reinforced carbon-carbon or the wing leading edge. So that's our priority 1 area, and there's, I don't think, any concern on anyone's part for both OV-103 and OV-104 that we'll be able to get the Zone 1s done on both vehicles before a spring, summer type launch window. When we get to Zones 2 and Zones 3, we will be inspecting every gap filler in those zones. We'll start from the forward of the vehicle and work our way aft because the ultimate effect of a protruding gap filler is felt downstream. So what we want to do is get rid of any opportunity for a protruding gap filler further up toward the nose of the vehicle. And we'll just work our way aft, and at the end of the day, we may or may not get 100% of every single gap filler in all 3 zones evaluated or removed and replaced when we're ready to go fly. But from a risk perspective, I see it as very low. To give you some feel for the type of margins we're talking about, the reinforced carbon-carbon in the panel 9 area we'll see on the order of 2,900 degrees Fahrenheit upon reentry. The amount of margin before we start to get into the multi-mission certification of the carbon itself is 3,250 degrees. So the margin area is just a few hundred degrees. With respect to the towel, though, we see on the order of 2,300 degrees Fahrenheit max, and the capability of the towel is above 3,000 degrees Fahrenheit. So again, we have, as you can see, significant delta margin on the towels compared to the carbon-carbon. So we think we have a good set of processes in place, and the priorities we think are appropriate, and we'll get done as much as we can get done, and we'll be ready to go fly.
Hi, it's Bill Hart with CBS News with two quick ones for Wayne. On the power amp, obviously, if you can just get rid of it, that resolves any questions about thermal cycles or cracks or whatever. And I know a lot of folks would like to do that. What do you think? I know you don't have a crystal ball, but I mean, how realistic is it that you can get your analysis certified in time to simply take it off for 121?
Well, Bill, you're exactly right. If we could eliminate those large pieces of foam, and I had a couple of numbers here. There's 2 of those ramps, and the hydrogen one that we've been talking about, the one that's in the hydrogen tank, is about 22 pounds of foam. Clearly, if you can eliminate that off the tank, then you have eliminated the possibility of having damage from debris that comes off of that ramp. And that's why it's a long-term goal of the program to get rid of that ramp. But you have to look at the other side. Why is the ramp there? We have gone back and looked very closely at the historical reasons for putting that wind deflector on the tank. If you'll remember those pictures that we showed a little bit earlier about the workmen working on removing the power ramp, next to them there's 2 pipes on the outside of the tank. Those 2 pipes carry the pressurization gas, hydrogen and oxygen, that are bled off the engines that keep the pressure up inside the tank. You can't fly without pressurizing the tanks. Also, a little bit more difficult to see right next to the ramp is a square metal box that carries the cables, the signals that open valves, take temperature and pressure readings from the tank, so on and so forth. Obviously, you can't fly without having that kind of control capability going to the inside of the tank, to the piece parts that make the propellant flow. So before you remove the wind deflector, you need to make sure that those structures won't come off in the supersonic flight regime that we see. So the aerodynamic process, which has greatly improved over where we were in 1979, 1980, 1981, is looking to see if really we have the structural margin in the system to fly without that protection that the foam ramp provides. The reason the foam ramps were put on, quite clearly, in those days nearly 30 years ago, 25 years ago, is that the aerodynamics indicated the structure was marginal to hold together during those aerodynamic supersonic loading periods when the shock waves off the tip of the solid rocket boosters interact with the side of the tank. Today, we think that there is a great deal of hope that we can prove that the structure, which has been improved over time, strengthened over time, can hold up to that buffet and not come off. But that is a risk that you do not take without having a good engineering analysis. So we're starting a campaign of wind tunnel tests, computational fluid dynamics modeling with the supercomputers to try to understand that better and frankly feed that back into the structural analysis that the engineers are going to perform to make sure that those parts stay on. It is possible that we may get there for the first flight. It is more likely that it will take us until the fall of next year to completely complete that work, but people are off looking at what it takes, what the resources would be to provide an accelerated but thorough analysis, and so we'll see where it leads. I think we're all clearly committed to the fact that the less of this manually applied foam or even automatically applied foam that we have on the outside of the tank, the less chance we have for it to come off and the less hazard we have.
Thanks very much for that detail. And a last quick one from me, and it's on a totally different topic, but could you give me an update on where you stand on whether or not you have to have certified Tyler RCC repair procedures given just a couple of years left in the program? Are we going to fly uncertified procedures, or do they have to be certified at some point?
Well, I don't want to go overboard with my answer. I hope I didn't do too bad last time for you, Bill. The answer is, of course, we would like to have certified tile or thermal protection system repair capability. The difficulty is in accomplishing that. What we have are some reasonable methods of thermal protection system damage repair that we believe will work, but to go to the certification level requires a great deal more time and energy. Some of those repairs I think we probably can certify in the life of the program. Some of the other proposed repairs appear that they will take longer than 5 years or so to achieve certification, and therefore it becomes problematic for us. We're going to use the best that we have available if we need it. And Steve, would you like to add anything to that discussion, because you're in charge of the whole repair effort?
Yeah, I think Wayne's touching on it very well. They're the two repair methods that I think we have the highest probability of certifying. One for RCC and one for tile is the NOAX material that we demonstrated as a detailed test objective on the last flight. It's TS-114, and then the emittance wash, again, which was demonstrated on the last flight as well. Both of those will provide a limited capability, but if we are to surmise what is a potential damage case, whether it be a crack on reinforced carbon-carbon or a damage impact on tile that's a little deeper than we would like, the NOAX and the emittance wash would work, we think, very well to accommodate a reentry. It's when you get to a scenario where if there were a damage of a whole type nature, then the amount of testing and analysis to gain a level of confidence we would want to have to be able to say we have a quote-unquote certified capability is really, and then the modeling that would go behind it is a very extensive effort. But I will add, we have a lot of good work that has been done, and there is clearly capability there, and how much capability we ultimately decide to fly as a program is something we'll be bringing forward as a recommendation to Wayne here in the next few weeks.
Todd Halverson of Florida Today, I guess for John Chapman. If you guys at this point have no Eureka or smoking gun on the loss of the power ramp on STS-114, can you tell us what the leading suspect is and what you've been able to rule out?
Well, Todd, I would hesitate to say that we've been trying to rule out very much. We're looking at all possibilities right now. The candidates that we're really looking at are the same ones that were derived early on in the investigation, and that is either a subsurface defect in the ramp itself that was caused by the spraying process that was used earlier in the program before we started developing the enhanced spray process that we use now for PAL ramps. And that possibly had created a defect that was then the source of cryo pumping to get cryogenic liquids into that defect that then could later expand upon ascent and pop off a piece of the ramp. That's one possible scenario. Another possible scenario would be when events sort of line up, where you might have a defect and you might have it in combination with the aerodynamic loads that the vehicle sees during ascent, and that could possibly have taken it off. Then there are combinations of these type of things that we're looking at. So that's all part of the testing program that's very extensive on PAL ramp. That's going to lead us to the bottom line root cause. That's where we're going right now. The question of how do these cracks that we've found figure into that? We don't know. It would certainly be premature to say that the cracks in the PAL ramp play a factor in that. We don't know that right now, but they might. So that's part of what the in-flight anomaly investigation team, along with the project and the engineering communities of the centers, is looking at right now.
Thanks. And for Wayne Hill, Wayne, we've been hearing a lot about the possibility of serial processing down here at Kennedy Space Center, and I'm wondering if you could discuss what move to serial processing would mean both to the workforce down here and your ability to complete the station as now envisioned, the 18+1 plan.
Well, you know, we have been going through several exercises as we develop the budget for the next 5 years. And that was a proposal that was made, I think, by some folks that perhaps aren't as familiar with how the work is done in Florida as many of us are. Frankly, the serial processing option doesn't save you very much money, and it greatly reduces your flight rate. So from my standpoint, it's probably a non-starter. We are working through a number of different options to contain costs in the out years as we get toward the end of the program. And I would just hasten to add that here in this fiscal year, we have been able to provide a budget that meets the guidelines that we were asked to meet, and provides a full level of safety and flexibility to fly the number of missions that we need to fly. And we'll continue to work on those options in the future. You know, the process of program management has to do not just with the technical content and making sure that everything is safe, but it also has to do with meeting a schedule, which is to say we want to complete the International Space Station by the time the Space Shuttle is retired in 2010. And it has to do with meeting a cost which the nation can afford, which the agency has allocated to the shuttle program. And I'm confident that we'll be able to do all three, but it's going to take a little bit of work to make sure that we meet all three of those constraints. And frankly, that's what they pay us to come here every day and do, is to work to meet all three of those constraints, to make sure that we're safe, to make sure that we complete our mission, and to make sure that we do it for the best cost to the taxpayer.
Okay, that's it from Florida. Let's head up the East Coast to Washington, D.C. and NASA headquarters.
Hi, this is Tracy Watson with USA Today. First, a quick clarification from Mr. Chapman, I think. I just want to make sure you did not see these cracks in the power ramp on the ET before it went to KSC, correct? And you did have techniques that would have allowed you to see those cracks before you shipped it. Am I understanding that correctly?
You are exactly right on both counts, Tracy. We did not see them before we shipped it, and before we shipped it, we looked at it with non-destructive evaluation techniques that would have seen these.
Okay, thank you. And for either you or Mr. Hale, I was wondering if you could walk me through the milestones you would need to hit to launch this spring. You know, when would you need to have your research done? When would you need to start respraying the tank? Just so I understand, you know, what the timelines involved. That would be very helpful. Thanks.
Well, let's see. I didn't bring a schedule with me, but let me see how I do off the top of my head. And John, you can keep me honest. We need to start reapplying the PAL ramps in the mid-January time frame. The final engineering reports are complete about the end of January. We have the testing wrapping up about mid-January, but the final report writing is at the end of January. The overlap there is something that we can handle in the sense that if we get something in the report that would give us pause, we can always go back and recycle again. The tank needs to be shipped from the Michoud assembly facility on about the first week in February. It takes 5 days to get to the Kennedy Space Center. From there, it's fairly compressed flow to get us to the opening of the May launch window. Now, I think you can see when I say that this is an assessment, that this does not present a firm launch schedule. It depends on how the testing comes out, how the reapplication of the PAL ramp comes out, if in fact elect to do that. And there are a number of technical issues along the way that would cause us to delay. But we have asked folks to start working, in particular when I talked to Steve Polis about things like gap filler tests, to prioritize their work to see how much they could get done to support the opening of the May window. If we get a delay in the tank, we would use that time profitably to continue other work on the orbiter or other parts of the Space Shuttle flight vehicle. We're going to be paced by the technical work, by the results of the testing, not by some schedule, whether it's arbitrary or just an assessment. We're going to proceed as the technical facts lead us.
Warren Leary with the New York Times. A couple of questions. First to Mr. Chapman. Are you pretty well assured that the small cracks you saw on the power ramp is not shipping damage that might have happened to that particular tank as it was being moved? And it might not have happened to the other tank that came back and forth?
At this point, we feel very confident that this was not shipping damage. However, as we dissect these locations and look at it closely, we don't want to preclude anything. But right now, we have no reason to believe that this was shipping related at all.
Okay, second question for Steve Polis on the thermal blankets. In your assessment of the post-114 assessment, was this ever really a safety problem that you had to deal with? And then, secondly, on the refabrication, you said you're going to replace 40 blankets on one shuttle, 60 on the other, out of 486. Was this stitching just badly done, or are you going to have a new stitching method to make sure that it doesn't unravel again? What type of change will you make in the new blankets that you're going to put on?
Well, let's see, quite a few questions in there. The safety concern was not one of a thermal nature when it all came down during the flight. we were concerned about the blanket potentially tearing away and then impacting another part of the shuttle vehicle, the orbiter itself. And what we were able to demonstrate through the wind tunnel testing was that was not going to be the case. And what we saw when we re-entered and the vehicle landed out in California, again, it frayed a little. Some of the internal batting material came out, but again, no liberation. So at the end of the day now, if we ever had a similar scenario, I think we would have much higher confidence that we were not going to see a liberation of the blanket itself. In the context of the stitching itself and why maybe we missed it, and what are we doing to ensure that we don't have a similar problem in the future, the way these blankets are manufactured, there is a closeout stitching and then a quilt stitching. So when you look at the blankets on the vehicle itself, it looks like a quilt for all intents and purposes, but there's a set of stitching that goes the entire way through the blanket itself, and that stitch layer is what ultimately gets bonded with the blanket base, and then the stitching gets bonded to the vehicle. As you look at it, at times a quilting stitch looks like a closeout stitch. So what we learned through this process is how to go in and ensure that we're looking at a quilt stitch versus a closeout stitch. Again, closeout's the one that goes through the entire depth of the blanket all the way down to the base. And in terms of manufacturing, we have that completely understood, and we know what we're going to be inspecting for, and we'll be able to go ahead and get that worked and not be a concern in the future.
Tracy Watford again. I don't know who should take this, but if memory serves correctly, the tank that flew on 114 did not get subject to the same number of tanking cycles as the tank on which you found the cracks. And I'm just wondering if you could, hypothesize for me about whether you might have had cracks on the 114 tank when it didn't see the same conditions.
I'll take that one, Tracy. In terms of how these cracks form and whether they are related to the number of thermal cycles that you see, that is precisely the type of information that our investigative team is looking at right now. Does it happen after one? Does it happen after multiple? What are the variables involved in that? A standard process that you go through in looking at the boundaries of what can cause problems. So we don't really know at this point what the specific cause of it is. But certainly that's a variable that we'll be looking at is the number of cryogenic cycles and pressure cycles that the tank is seeing.
Okay, coast to coast out to California in the Jet Propulsion Laboratory for our final questions.
Yes, this is Mike Dornheim with Aviation Week. I just wanted to follow up a little bit on that stitching question. I understand, I guess, the difference between a quilt and a closeout stitch, but I have no idea what that has to do with the stitch coming apart. Could you explain a little further what the problem was with the stitching and how that's going to be resolved? Why did it come apart?
Okay, I'm sorry, I may not have made that clear. What we have found through the inspections is there are some areas where the stitching has either been broken or is missing. So it was under that scenario, whether it was broken or missing for this particular anomaly that we saw during STS-114, we're not sure, but not having the stitching there, or if it was broken, allowed for the blanket to essentially fail at a localized point, and then upon ascent, when we saw some additional air loading, it ultimately billowed up like a pillow almost, and that's what we saw when we got on orbit.
Okay, and then I just wanted to understand on where the cracks were found. That's ET-120 is my impression. And then I also wanted to know, my impression was that tank was not intended to come back to Michoud. My impression is it was to go up, and it was because of the problems with the fill sensors or whatever that it ended up being returned. So am I correct in sensing that the cracks are essentially a serendipitous discovery?
Well, let's say yes, ET-120 was the tank that we're talking about. The intention for ET-120 was to launch it and fly it on our return to flight tank. It got set to the side because of some of the problems that we encountered during the tanking test. It got sent back to Michoud along with all the other tanks as part of the investigation on the foam. When you say serendipitous, yes, it's serendipitous in the sense that we found something that we did not expect to find, but it is the result of having a very good set of techniques and having a plan to look very hard that we found these particular indications on this particular tank.
This is John Johnson, Los Angeles Times. It seems to me that there's a lot left to be done on the power amp, and I just wonder, are you adhering to the May date because it's something that you've had until now and you don't have any reason to set it aside, or do you realistically think you can make that date?
Well, let me address that. Okay, guys, people talk to us about schedule pressure. I'm going to tell you something. The only people I get schedule pressure from is the media when they ask questions like that. We have not set a launch date. I've said that I don't know how many times in media briefings. We have not set a launch date. We are working through the investigation. We have assessed the schedule, and if the testing gets completed as it's planned, and if it comes out the way we think it might likely come out, then we think there is a probability that we will be able to launch in May. But we have not set that as a schedule. It is not driving us. I'm going to put this in very simple words in plain English. The results of the technical investigation are going to allow us to fly. We are not driving to a date on a calendar that was set arbitrarily. We are not allowing ourselves to be driven to do something stupid because of some schedule date. We are not doing that. And the only people, quite frankly, that I get pressure from on launch schedules is the media. Okay?
Yes, this is Mike Bernheim again. On that panel, I think it was panel 8, right? Is that going to be replaced? And there was also the anomaly on the fibrite T-seal, and that was going to be strength checked. And I was just wondering how you strength check something like that.
See, the panel 8R is going to be replaced. We have a spare at the Kennedy Space Center. So the early indications of coating separation, we'll be able to send that panel back to our vendor and have it repaired and then put back in the spares long before we're ready to go fly again. In terms of our reinforced carbon-carbon, anytime we find a void or an internal indication of, and I don't want to use the word damage because it's not damage per se, it's an inherent possibility when you're laying up 19 plies of composite that you might have some internal voids or internal separation of the plies. We've developed the techniques to go off and analyze that from a stress perspective, and that's how we're going off and analyzing this particular T-seal, and they're showing that under all loading conditions, ascent and reentry, we have positive margins of safety.
Okay, that's all the time we have for the briefing today.